Thank you so much, everyone, for joining. My name is Sachin Gupta. I'm a solution technical architect at CG Infinity. Today, I'm excited to present you the domain-driven design, a design concept in building the application, understanding the business that helps you build a better application. How many of you relates and agree with me what this statement says from Alberto Brandolini, that it's a developer understanding or misunderstanding, not the domain expert knowledge that gets released in production. In simple terms, is the developer's understanding that goes to production, not the business domain knowledge. And in the yesterday keynote, Matt McDowell also emphasized domain knowledge as a most important skill a developer can have. So what it leads when the developer doesn't have the understanding what they are building. When they get the user story from the business analyst, and this would happen. And that's exactly what it looks like in code. This is an example of taken from a retail application that developers build a model for customer. They're multi. No worries. I think it's a technical difficulty we have. Are we up? Okay. All right. No worries. Thanks for catching that. So yeah, that's what happened if you see on my screen. If it is, yeah, I think visible enough. So the business asked to create a customer management system, and there are a bunch of different teams there that managing the customer engagements. There are sales team, support, the billing department, and the marketing, and developer understand them and what they have in their system. And I hope you are sort of technical just to understand that how developer puts everything in a one place. They have discount calculation for the sales team and creating support tickets for support team. They also refund from the same system, of course, because it's a one system for the end customer or the user. Now, when we pause, look be similar. We have all seen that. Maybe we have built it ourselves. One class trying to serve everyone. And the sales need discounts, calculations, support need ticket management, so on. Somehow it ends up in a same place. Now, what's wrong with that? So when the change comes up and say, customer call to update their phone numbers and show how multiple flow it goes through, it shows the support team, it create ticket to and update the customer contact info. It also log the support interaction. The marketing team get updates on the customer update, and they will update the marketing preference. All happen in the one place, but how many teams own that change? We can say multiple, but not the one developer. It leads to a misunderstanding of is the customer means same to the different departments, and looks like it's not. And how we gonna solve this problem?
Interfaces.
Yes, there are some concept, we call it domain-driven design, that give us a way out. Instead of having one class or customer service that serving everyone, we create different bounded contexts. I'm using some big words here, but just to prepare also what's coming. Now, DDD solve this problem by creating its own market bounded context. Now, what the bounded context, I'll come to that later, but quickly show you what we are seeing it here is the sales have their own context of how they serve the customer and what does customer mean to them. We have sales customer that only deals with the customer type, which is prospect, lead, customer. They might not become the customer at all because they might be just prospects, and they don't need to have what the marketing segments of the customer and their billing because they might not become the customer to this organization. We are marketing customer, its marketing specific details and their actions or the behavior the marketing supports to the customers, like updating marketing preference, mailing list, trigger, contact, update email, so on, and so as billing and support. I'll not go in detail, but you get the idea that how thinking of a system as an individual departments, because they are different departments in organization, but when the developer does not get that, they ended up producing what we just saw in the previous slide. Now, what you saw is DDD in action. Now, let's name this pattern and understand the principle behind them. So, presenting domain-driven design, it's not a new concept. I mean, if you, of course, aware of this book is maybe 23 years ago, Crick Evans, he formalized this foundation book on the domain-driven design. So just to call out, it's domain-driven design. It aligns the software with how business teams actually work. Instead of using one system or the one system trying to serve everyone, you create a focused area that matches real business requirements. Each team gets their own language and clear ownership. So not a customer will be a sales customer or prospect to the sales, but not a account or a billing account for the billing team. The software become a direct reflection of the business expertise, not just the technical decisions. So it's a philosophy and a set of practices that places the business domain at the center of the software development. Moving on to some of the design concept, and I divide those. There are two strategic concepts or design patterns, and they are tactical. Go with the strategic one. It's ubiquitous language. We touch base when we talk about customer is not a universal model or entity in a system. So ubiquitous language can help us bridge that gap between how developer get the that particular actor or a entity, and how the domain expert in each bounded context understand that. So it's a common language bridging developers and domain experts for clear domain understanding and no more translation. Every time you are in a meeting, talk about, hey, this is customer, how I end the customer call. So when you're talking to the sales team, it will be it's a prospect calling us, not the customer. But when it becomes the customer, the billing team refer that as an account. So it's just how different teams use different terminology or names for the same entity that a developer use in the system. When the support escalates, the ticket marketing here, upsell opportunity, and same customer for different meaning. These terms should be used identical by both business stakeholders and developers and appear in the code. It reduces ambiguity, not to say one developer saying something else there and business otherwise, because the business has to clarify every time they're in the same room, or the developer gets it differently. There's some challenge. Business speaks one way because they want to see they use the they don't use the technical terms, while the same words can mean different meaning. So just want to you'll be using ubiquitous language throughout the application lifecycle, from getting the requirements to writing the user story and getting into the system. it helps long run having developer carry the continuous understanding the system. Next concept is bounded context. So we touch base on our example is a clear boundaries. It clear the boundary that separate how different teams think about the same business concept. Sales has its own customer model, prospects, lifetime, support has theirs. We covered that already. In example, you see that although the customer is the same customer when they are in the system, but their attributes are different. So it must be developed in that manner. Means they don't need to share a single giant customer entity that have everything possible for that customer. So remember our messy customer service, that bounded context gave us the sales, customer service, and support service that we saw. Now, how?
So, are you also saying that each department has their own copy of the same customer, prospect, name, address, phone number?
Yeah, I touched base quickly, but we can discuss more. But yes, you can create a copy, but I don't want to go into the implementation about different syncing problem and so on. But yes, they should have a subset of the data. If it's implementation details, whether it's a copy and syncing issue, but yes, it's a same customer with a limited information, because they don't need to be, sales doesn't need to aware about the billing, and billing doesn't need to know about the tickets that customer has.
I mentioned syncing is a big challenge. I think one of the biggest pain points for customers is probably that one hand doesn't know what the other hand's doing when they're having to repeat the same information from the same answers to different departments.
Exactly, and that's why domain-driven design is not just for a simple system. It's inherently complex because our business is complex, and when it grows, it becomes more complex. So I think I was in another talk yesterday, talk about that. We don't use DDD or these concepts on a simple application where you can live without that. So coming back to the example, the bounded context, how you do that. So you need to draw clear lines where your business naturally separates, engage the domain experts, because the developers, if you move your carrier from one domain to another, you don't carry the domain knowledge. So talk to the domain experts, talk to the actual sales team, understand how their language shifts so that you can build their model accordingly. Map the boundaries and draw lines where responsibility separates, like sales, support, and the support customer. A bounded context is just not just a technical boundary, it's a semantic boundary where a particular model applies consistently. Now we move to the tactical design, like how we implement that. They are domain models. They are the building blocks that brings bounded context to life. So you have entities. Those are the objects, like we have seen our customer, sales customer that has ID that can be identified uniquely, although the same customer with the same name can exist in the system if they have the different identity. Value objects, that's my favorite one. They are defined by their attributes, like email and money. Aggregates a group of related objects with consistent boundaries. I'll touch base on that. An object model of a domain, it incorporates both behavior and the data. So don't confuse the domain model with their DTOs or your anemic model, which should only carry the data. Quick overview on entities and value objects. You see that sales customer only have limited, it has the customer ID that identify customer, while first name, last name, email, of course, they can't have, but it identify by the ID. However, it's compared to the value objects, which is very helpful. It help keeping the some of the validations and business and the domain, I would say, functionality of a particular object keep close to it so that we don't replicate, like email and money is the other example which I don't have the so any operation or some helper methods you can keep to the value objects. Value object doesn't have any ID because it's, as I said, its attributes are their identity. Next, aggregates. Now aggregates is also a entity, but it's the goal of this pattern, if you have one defining an aggregate, is to protect the consistency, because once you have multiple entities and you have let's say for example order, you don't want your clients to deal with the order items, create order items, calculate the total like in their application. You want to keep it with the business model itself. So when you aggregate is it helps the orchestrate the application layer so that it can only interface with the aggregates behavior action and not dealing with the entities directly. So it is it's a kind of interfacing layer for your application, not the business. So just to highlight the difference in business domain model, it doesn't know anything about anything outside of the domain itself. It doesn't know about the database. It doesn't know about the your infrastructure or anything else. It's pure objects. That make it more helpful to test and change without any impact to the rest of the system. And you see that the entity that's used in the order item, the other world, the outside world doesn't need to use it directly because that's what the order entity does. Order ensure total is calculated correctly when the item changes, so no one needs to replicate that logic across the system. Now the next most important one is domain events. So when you have different aggregates like order or support service or support, how they interact with each other. In our previous example, when a customer called to update their contact details and support team is updating their contacts, they want to notify the marketing team that customer has changed. So that's how they synchronize. They let the other rest of the system know that something happened. So domain events that helps bounded contacts communicate without tight coupling. So they don't need to look for the table or the entity like when you're changing it. Instead, they're relying on the events that happen on a system. So customer is changed, customer was escalated, an order was placed. It's represent business events. So it's helpful to that's how in the real world the organization works. They do not notify the department do their own due diligence. It enables loose coupling. Support can notify sales without knowing sales exists, because it's the sales that need to know when the contact changes or something happened for the customer. It captures the business intent, even use the business language, like as I said, order place. There's no other thing about, hey, transaction is logged into the system, do what you want to do. It's more about business events. Quickly, the next one. So, just to, as I said, coming back to I've finished the tactical and the other patterns. However, there are other patterns exist, but they are more on the implementation side. I'll quickly go over that, but let's talk about some common pitfall and the best practice. That's how you should follow when applying a DDD. And it's it should be a gradual move. you can't simply change your system to use a DDD. Um, so applying all DDD patterns to simple problems, as I said in the beginning, that over-engineering simple domains can lead to unnecessary complexity. So yes, DDD brings complexity in the system, as you mentioned about the consistency of the data, replication of the data. But as the system grows, imagine like retail organization like Amazon and others, how big they are, how um, distributed they are. They can't rely on the one system to operate. So they are, as I said, applying a simple domain is unnecessary for the DDD. Neglecting the ubiquitous language. So keep the business terms in your code. It helps developers understand continuously improving their business knowledge, because if they keep focusing on the technical jargons, they're gonna lose of the business. So what happen is they produce and the same user story come back to them, because they don't get the intent of what they are developing. Because as a developer, we got the user story, we take it as a task, we implement it and say, yeah, I'm done, give me the next thing. So yeah, it improve communication, transparency within an organization. Fuzzy boundaries, so having a clearly defined boundary context and the boundaries, it helps build a robust system, or in the system, in the organization as well as in your application as well. Failure to clearly define bounding context leads to a model confusion. So when you start with when you're creating a bounded context, make sure the boundaries are defined, because you need to know when this is not the part of the system, your boundaries, like sales is where the sales support ends and the customer support or the start. So the boundaries, if the boundaries are fuzzy, it shows in the system as well. Where we go from here, starts with the ubiquitous language. If you're not understand, or your business use a different language, naming certain actors, certain process, and identify the bounded context, how supports and sales team and your IT versus other team, they use what different terminology they use. Once you understand that, create the model, and then choose the tools. Now coming back to some patterns and some tools which you can leverage. As I said, DDD is not a new; it's been around for a very long time, and so they are very mature system and framework access. Some architecture patterns like clean architecture, CQRS, and event sourcing. This is more from a easy to the complex. I think event sourcing is one of the complex. It brings a lot of complexity, but it's when it works for a system where event, you need to understand what happened in the past. Event sourcing is one of the most important way to accomplish that. Domain layer, use repository or the entity frameworks to deal with the backend, as we have not touched about anything about the database, because it's more like an implementation side. But using repository without knowing what's under the hood can help your domain layer clean. Domain service and factory patterns are some of the patterns which you can use to define your domain layer, so that you focus on the domain, but abstract how those domains are discovered. Application layer, they are application service patterns, or the mediator, where you need to notify the rest other system, is mediator R is one of them. Some infrastructure pattern like adapter, yesterday someone was explaining port and adapters is one of them, and anti-corruption layer. So many tools exist to implement this pattern, but master the concept first. There are some reference and credit I want to highlight that this is my reference for this talk. recommended these two books if you haven't read them. It's clarify a lot of the basic concepts. Thank you. There are some session slides and which you can use this to refer and feel free to contact me on LinkedIn. Thanks so much for all.
It's more of a comment than a question. I know this is focusing on like high level, class level, domain driven, so matching your internal terms to the domain terms. I think it needs to be said that even at the lowest level, even at the statement data level, you need to do that also.
Yeah.
Yeah, the business rule says if something's greater than equal to 1, then code it as greater than equal to 1. Don't code it as greater than 0. You know?
Yeah, coming back to your example.
If it says day 1 to day 2 inclusive, implicitly inclusive, that's what natural language implies. Don't say day 1 to less than day 2 plus 1. You know?
Exactly.
So I have one question. So do you suggest that we have implemented the whole application on edge-driven and we are going to develop the new features? So it should be possible to move it towards domain-driven. So can both will we work together or not?
Like part of the system.
Microphone check, check, check. There's a little hum. Yeah. Is that coming from me? Yeah, one sec. Microphone check. We good? Cool. We good? Yep. All right, so should I start? All right. All right, so we're going to get started. Today, I'm going to be talking about migrating 600,000 lines of code from Flow to TypeScript. So first, a little bit about me. I am Chris Griffin. Oh, actually, hold on. Let me make sure this server's running. There we go. OK, so a little bit about me. I've been a dev for around 10 years. I just got into developer advocacy at GitKraken in the past year and a half or so. And I'm really liking it. I get to make content and come out to events like this and speak. I program on Twitch in the software and game dev category. I do that like 5 days a week, which is really fun. Yep, I see another streamer out there. And I love snowboarding. It's my favorite thing to do besides streaming. They're probably tied at this point. So if you want to get any of my socials, this is the QR code. I'll be showing that later if you want to scan that, and you should be able to grab it from the recording later. So first off, what is GitKraken? If you haven't heard of it, our main product is a desktop application. It's an Electron app, and it just makes Git easier to work with. It's really cool, actually, like the way you can visualize things using the graph and a bunch of the cool AI features we've added lately. This isn't a product pitch, but it is about how we rewrote this entire app. So I do have to at least explain what it is. So just a little bit of the product part. We do more than just this desktop GUI. We also have GitLens and VS Code, if you guys have used that before. Yep, I'm a big fan. I always have VS Code installed, or GitLens installed in VS Code, but I forget about it all the time. And then when I set up a new machine, oh, wait, where are my annotations? Where's those like inline blame? So yeah, one of those tools that kind of flies under the radar for a bit, but incredibly useful. And we have all sorts of other stuff, too. I definitely think check it out if you want. But let's dig into the history of GitKraken. So the company is originally called Axosoft, and we have rebranded to GitKraken based upon this product. Technically, the company is still Axosoft, but we do business as GitKraken. And Axosoft made this thing called Glow boards, which is basically like a Kanban board, like a Trello board, or things that you might see in Jira and all that stuff. I've never actually used it myself, and this was the most recent screenshot I could grab. And it says GitKraken in some places on here. No, this is actually a new, older one. So yeah, it's actually hard to find something on the internet from 10 years ago. It's crazy. So it was born out of an internal hackathon we did as Axosoft. And I think that's really cool. Like, more companies should do these internal hackathons, building products and just letting your devs be creative. It's really fun. So yes, we built this because our team was having issues using Git, and we decided to just build something. And back then, Electron was still pretty new, right? Atom still existed, and we were using React, and it was cool. But we wrote it with just regular JavaScript. So instead, by 2017, we needed to choose a type system, right? The application was growing very big, and if you don't have a type system, some really easy bugs can crop up in your apps. So, right, like why? You know, I just explained a little bit, but you know, it's a better developer experience. You get feedback at dev time instead of just runtime, and that means that you can catch bugs earlier, so you're giving your users a better experience as well. Type systems just really help us be more productive. And at the time, there were basically like 3 big ways to do a type system on top of JavaScript. There was Flow, made by Facebook. There's TypeScript, which I think most of us are probably familiar with at this point. And then there was a thing called Reason, which is basically a flavor of OCaml, and it had very strong type safety. It was used in the Facebook Messenger app, at least at one point. And it's really cool, but Reason, you have to write like a totally different language. The interop with JavaScript is a little tougher, and you have to like write all of your types because no one makes Reason types that they ship with third-party libraries. So let's dig into what Flow is. It was made by Facebook and open sourced in 2014, and it's still used in React today. Even though Facebook ships types now that are TypeScript types, they're still using React internally, and they're probably using it in all sorts of other parts of their code base too. But pretty useful, and it was popular enough at the time, like because we were using React, we decided let's use what Facebook uses. So we had picked Flow at the time. And here's a quick syntax example. If it's a little small, it basically looks a lot like TypeScript. So the only difference we can really see between TypeScript and Flow in this case is the position of the optional like question mark for a property that doesn't have to be there. Here in Flow, it goes right before the type instead of on the property. Pretty simple, but there's other differences too, especially when you start looking in like how they do their type checking. So in this myfunc function, we're doing a check for if foo.bar, and then we do a console.log, and then we do the return of foo.bar, but Flow doesn't actually know that foo.bar is still there anymore because it is very strict about where side effects can come from. And if you're unfamiliar with functional programming and side effects, it just means that this technically console.log is creating a side effect by printing something to your dev tools, right? So it doesn't know that. It doesn't know that console.log is a safe side effect. It could actually be modifying state all over the place. And if you wanted to hack on it, right, it's just JavaScript. You can hack on console.log and alias things and do all sorts of fun stuff. It may actually cause side effects that you don't even know about. So when we really want to like compare these things and understand how the migration worked and what the syntax differences are, let's look at a couple snippets of code between Flow and TypeScript. And let's like think about how they are different. So Flow is a Babel plugin. So Babel is the compiler, and then it's just a plugin for that with a parser and all that stuff, whereas TypeScript ships its own compiler. Right now, TypeScript's compiler is written in TypeScript, which is weird, right? Bootstrapping and all. But eventually, they're going to change it to Go just so that we can get faster compilation times. But because they own the compiler, they can make decisions like that, whereas Flow is just stuck with whatever Babel does, basically. Another big difference between them is how they do type inference. So Flow is much stronger at inferring the types without you having to explicitly state these things, whereas TypeScript generally prefers that you annotate things so that it can figure stuff out a little quicker. And this kind of gets into why we had to migrate, because Flow is so strong at inferring these types, it's doing a lot of checks at dev time that can slow you down. Another big part, nominal versus structural typing. In this case, nominal just means by name, if you haven't heard that term before. Both are mostly structural, and that just means that they're going to look at the props and the names of things and assume that those types might be the same thing, or at least like let you use them in a similar way. But Flow will not let you do that with classes. So all classes are strictly by the name of the class. Doesn't matter if they have the same props, like this snippet that I have here, right? We see class foo with name string, and then class bar with name string. In TypeScript, right, we have this function called sayName, and we pass in a bar to it. That's totally fine. In Flow, this would be an error. So definitely some subtle differences in how you use these things. And then strict structural typing. So in general, in Flow, you are not allowed to add extra props. So in this example, we have our type user. We have a function called printUser that takes in user and then :user. And then from there, we just like print out a user1, which is using this like user type. Then we have const user2, which is an ad hoc object that has the same structural shape as user1, but we add this extra prop. In Flow, that print user with user2 is an error. So some of these subtle differences between these means that it's not just straightforward switching between Flow and TypeScript, because they're going to complain about different things at compilation time. And then finally, just to reiterate, where the question mark goes for optional properties, it can definitely be a little confusing at first, but it's not something that you would want to go through 600,000 lines of code and change individually. So we're going to get into how we did that here in a second. So first off, why did we migrate? Well, like I said, popularity is a big part of it, but speed of our developers was a big part too. This is not necessarily the best graph. This is just using Google search trends, and we can see that TypeScript is actually really easy to search for. Flow, not necessarily. You have to add that JS to it. And over time, Flow has not gotten much popular as far as search trends go, but maybe I picked the wrong keys to make this graph. But this actually shows us a lot more. So we can see that Babel preset Flow, the library that you would download to actually compile Flow, is that blue line, and then TypeScript is the orange line. Nowadays, it's obvious, just use TypeScript. But back then, back in 2017, those lines were much closer together, so it wasn't as obvious. So we can be forgiven for making a decision at the time that wasn't quite the best one. And then here's another big part, type availability. So when you're using third-party libraries, do you want to write all of your custom types for those things? You're going to have to look at how they're used, where it's happening. Instead, you can use this centralized type repository called definitely typed for TypeScript. You used to have to get your React types from definitely typed. Now that they ship that with the library, it's so much nicer. But flow typed also exists for flow packages. When we look at the repos on GitHub, there's 8,600 packages supported for TypeScript, but only around 1,000 for flow. And if we start thinking about that, these are just the ones that are in the central repository. If we look at the package-specific ones where they might ship their own types, I did this search on GitHub. It's not very scientific, but it's easy to find the TypeScript ones, because they define types, and then whatever inside of their package JSON. For the flow, it's a lot harder, because there isn't a place to do that in the package.json, so you have to look for maybe this like module.js.flow file that'll have all the types. And Flow will generally look for that in your third-party dependencies, but these aren't necessarily going to be on a GitHub repo because it's a build artifact instead of something that you would like commit. So it's not a great search, but it does at least kind of like give you a little perspective. 1.1 million results for the package JSON stuff, and then 800 results for module.js.flow. Not very popular right now. So another big reason we wanted to migrate is because we were having performance problems with an older version of Flow. And it's something that they may have fixed in recent versions of Flow, but when we tried to upgrade, things broke. Because they were changing enough things over time that some types would work in an old version of Flow, but they wouldn't work in a new version of Flow. Or just how we were structuring our application, it would have been just as much effort to upgrade Flow as it would have been to switch to TypeScript. So when you think about it, though, we all know TypeScript. Can I see some hands of who hasn't used TypeScript? Or who has? That's more fun. Everyone. All right, perfect. So yeah, we can hire someone who knows TypeScript, and they can be productive within one day. Whereas Flow, there's all these little idiosyncrasies that are different that you'd have to train someone up, and there's going to be some growing pains of getting them into the org and teaching them how to use the code. So now, right, the why, that's fun, but how is way more fun. So we ended up having one really dedicated dev, John Alden, awesome senior dev here at GitKraken, and he just took it on himself to see if he could do it. So he had a fork, or a branch, of GitKraken Desktop that he was constantly pulling from main, because we're always shipping new code, and he was just seeing how close we could get in an automated fashion. So we probably wouldn't have been able to do this nearly as quickly without his effort. Very good dude. But the how of it is he used this thing called a code mod from Stripe. So Stripe actually migrated millions of lines of code. And I'll get into what a code mod is here in a second, but yes, we were basically following in the footsteps of someone who did way more work in this space, and it just, it was nice for us to follow in that path without having to forge it ourselves. So yes, they migrated millions of lines of code, crazy. And there's a quote that is from Mike Fix, engineer at Stripe. Seriously unreal. I remember a short time ago laughing at the idea of TypeScript ever landing at Stripe, and then I woke up Monday morning and it was here. And he crosses out Christmas because it's like it was a Christmas present, right? Being able to just have TypeScript in your code base like that, and devs could just be more productive and moving. So let's dig into what a code mod actually is. A code mod is a way of using the abstract syntax tree. And the abstract syntax tree is basically these nodes that make up your code. So if you have a statement sequence, like a function, it might have a while loop inside of it and a return value. That while loop is then made up of the condition and the body. And the condition has these like compare, op, and like the operation that you're doing between these things. And these are all just nodes, like objects, that make up your code base. This is what your compiler sees. This is what the parsers see. So this is one of those things that is hugely powerful. When you start learning about abstract syntax trees, you start seeing them everywhere. TypeScript's using one. You can get access to the TypeScript abstract syntax trees just by using the compiler in your code. So you can start making your own code mods. It's pretty easy, actually. But yes, very interesting to just like see this pattern of this tree of nodes. And the code mod goes through and modifies them. So what we can see is that this flow to TypeScript code mod has 3 major commands or functions. There's setup to install TypeScript and set up type declarations for some things and stuff like that. And then the big work happens with convert, which is using Babel to convert your files from Flow to TypeScript. Because, again, Babel's a compiler, it's a parser, and it has access to the abstract syntax tree for you. And you need Flow to understand Flow, right? So you can't like break down an abstract syntax tree of Flow using the TypeScript compiler. It's a totally different syntax. So it uses Babel first, and then modifies that into TypeScript. And then finally, there's this fix where, yes, that first step isn't going to be perfect, and the fix goes through and uses the TypeScript compiler to then respond and deal with the errors that are going to happen inevitably. So was it perfect? Did it work first try? No. Nope, definitely not. So what went wrong? Well, we were using third-party libraries, and like we saw, not many third-party libraries shipped flow types. So instead, we had to write our own. And it turns out that the custom types we wrote weren't one-to-one with what they were shipping in TypeScript. So when we tried to compile, it would error out and tell us that, oh yeah, this type doesn't match what the library is actually giving you. And at that point, like, yes, the third-party custom types was a fix we had to do, but also, like, how many people can just stop working and work on tech debt, right? Like, no, you have features to ship. You have bugs to fix. So luckily, we do have the idea of tech debt sprints that happen, I believe, like, near the end of the year-ish, just to make sure that we are solving problems, and also, like, people are going on vacation anyway, so you're not going to get that much done during November and December. But yes, during this tech debt sprint, it came up like, hey, we'd love to switch to TypeScript. And, our director of engineering asked, how long is it going to take? And our ambitious dev, John Alden, said, oh, a couple days. At which point she squinted, and our director of engineering did not believe him. Said, how about a week? And OK, he gave it a shot. He tried it within a week. And within that week, boom, he had it done and working. So it was similar to that Christmas idea from the Stripe stuff. So now let's look at the results of what we did. So number 1, faster build times. I had to go through our builds on GitHub Actions, and I went back and looked at how long these things were taking like a year and a half ago, 2 years ago, and they were like 40 minutes long. That's not great. If you only have one runner, you're going to have one like PR push, and then someone's waiting 40 minutes for that to finish. And then the next person who maybe pushes code 5 minutes after you has to wait 45 minutes or whatever, right? Like you're compounding all of this as this chain of like builds that need to happen. So number 1, you could just add more like agents and stuff, but that's just throwing money at the problem, when instead you can optimize things better. And TypeScript was able to compile in basically half the time, which is a huge win for us. It's a better developer experience. We were getting faster in-editor feedback. So our devs, right, when you're maybe writing some code and you're checking for, or you're using a property on an object, and then all of a sudden TypeScript tells you that object could be undefined. That was taking like 30 seconds in Flow, right? You'd write your code and you could get up and like grab a coffee or something and then come back and finally have the type told to you. Instead, with TypeScript, you get that within seconds. And like with a 600,000 line code base, that's really impressive actually, because TypeScript focuses on the file first and then spiders out, whereas Flow looks at the entire code base. So it kind of makes sense. Next, fewer custom types, right? Like all these libraries ship types for us now, so we could like delete code, and that's the best thing ever, right? I love deleting code. It's my favorite part of programming. And faster dev onboarding, right? We've been hiring because we're growing, and we have more features we want to ship, like all this AI stuff. We have devs that are able to just be productive within a day, just hammering out code, being productive, making stuff happen. So that's about what I got right now. It looks like I got about 6 minutes, so I could take some questions if we want. There's my slides if you want to, or not my slides, there's my socials, and I can post my slides wherever. I guess the Discord is probably the right place. Okay. So yeah, any questions? Yeah?
Is there anything you miss from Flow that you just don't get in TypeScript?
I think some of the stricter inference, right? Just being able to know what a type is without having to tell it is pretty nice. So it's just less code to write, really. Anyone else? Yeah.
So if your builds are still taking 20 minutes, does that mean you run those builds and like deploy? Does it take at least 20 minutes for every deploy, or?
I think so, yes.
PRs?
Well, so technically, GitKraken Desktop is it's a binary. So we're not like deploying out to a server. It's just a just a build that happens, and we get the artifacts. Yeah.
So my team does currently use GitLens, but we're still pretty new to it, figuring out the features. So what's your favorite feature of GitLens?
Ooh, my favorite feature of GitLens? I mean, that inline blame is just like so useful. Like you can hover it and get like all of the info about the commit. I really like that part. The commit graph is really nice. Like if you open the commit graph, you see this like timeline. And I like merging instead of rebasing, so you get this like Zen garden of like branches merging. It's really nice.
Yeah, we like that one. We like the graph too.
Yep. Okay. Awesome. Yeah.
Any new features or tools coming out for GitKraken?
Yeah, I mean, we're working a lot on our AI stuff. We just published an MCP server that uses a lot of our like services, so you can have all your integrations with Jira and GitHub and all that, and you can query using Cursor or whatever and use these tools from our MCP server. And we just launched that within GitLens, I think, within the past week. So you don't even have to like do anything with GitLens. If you're on a new enough version of VS Code, it'll install for you, and you can just start using it. Anyone else? Yes? Oh, thank you. I appreciate that. All right. Oh, yeah.
Have you guys tried out the Go compiler?
I haven't yet. Have you?
No, but I just was wondering because they're saying it's an average of 10x build time.
Oh, so that might be good. Yeah, we'll have to check that.
10 minutes to 2 minutes.
Yeah. All right. Yeah, I'll see. I bet John Alden's probably got some branch. All right. Anything else? I just want to make sure I don't leave anyone out. Yeah.
Can you talk about a time where maybe like you guys were dealing with outages or like a deployment that just went south, and like how you guys were taking those?
So again, because GitKraken Desktop is just a binary that you ship, there's less there, but we do have this like build server that when that goes down, like it was very flaky for a little while, so we improved our build server as well, and that helped. Just building for like different platforms and OSs. Yes?
Have you considered introducing
Effect? Effect is tough because once you start using it, it kind of like pollutes the entire code base. You got to use it all the way down. So we haven't necessarily done that at all. And with 600,000 lines, that would be tough. But it is very compelling. Like it's a cool library. I think it would make the most sense even if we started using it in some of our back-end services, like microservices and stuff. All right. I think that wraps it up. Cool. Thank you so much.
All right, we'll go ahead and get started. Thanks for everybody for coming right after lunch. Hopefully you don't fall asleep on me. I'll try to make this interactive. And also, do I have a little static? Let me move this over. If I stay all the way to the end, because I have something for everyone that has joined here. And yeah, let's jump into spec-driven development. Now, throughout this slides that I'm giving today, you'll see this ghost on it. He'll be kind of bouncing up and down. So the idea is this is a part of a new product that we launched. I'm going to talk a little bit about it, and it goes directly in with spec-driven development. I'm Eric, by the way. I'm a senior developer advocate at AWS. So I get to play around with a lot of these cool technologies and come out and talk to you guys about it. By the way, did anybody see Dennis Ivy's talk earlier? I'm singling him out. Because he actually went over a little bit of what we're going to talk about today. So I'm glad some of you have not seen that, because this might be a little bit of a repeat on some of those things. So what is spec-driven development? Now, it's not Spectre like we see here. It's a little bit of a different idea. And by the way, throughout this talk, I'm going to give plenty of time at the end for questions, or I'll be out there to answer some more when we're done, depending on how long this goes. So it's a development approach where detailed, structured specifications are created before any code is written. And the way I like to think about that is that we're doing all the upfront work before we jump into the actual coding part. And this lends itself well to coding with AI agents. And we'll talk more about what that is all about. So for those who don't know, there's this idea of specs. So what are specs? And I'm going to give you another definition before we get too far in. So specs refers to the formal requirements, rules, and constraints that govern the creation and behavior of a system. Back in the day, I remember creating requirements documents and having this waterfall methodology that we know and loved. Anybody use the waterfall or have heard of it? It's kind of pre-agile, almost everyone. So you had to create these huge, large requirements documents with every little thing that you thought would be in this system that you're trying to create. And then you would have to have a development cycle where people just looked at that requirements document. They worked on it for perhaps weeks or months, and there was very little agile about it. Now, that didn't really work well when we found out that maybe we should have these smaller sprints that need to be more agile, that requirements change quickly, and that we can break big tasks up into small pieces. However, with specs and with this spec-driven development, AI actually does really well if we create larger requirements documents and more detail, because it adds it to the context of the coding agents that we're using. And then it can more clearly and more thoroughly create the features and projects that we expected. So I just want to say that this is kind of the way I feel like it's kind of the future a little bit of what we're doing with these coding assistants. We're going to talk a little bit about vibe coding. We've had this vibe coding way of going back and forth, but maybe there's a better way where we can give the AIs a lot of context so we can do a better job at the output. So we actually had this problem at AWS. We're a huge company, an amazing amount of developers, and we had a lot of us internally using these tools, and then externally from our customers, we're using these coding agents and tools. And they were finding out that this vibe coding back and forth way wasn't providing exactly what they wanted. They wanted something more. And so a lot of our solution architects, a lot of the people internally found out there's a better way to kind of handle it, and we came up with a spec-driven development way of doing it. One of our early attempts at AI coding agents, I don't know, anybody here heard of Amazon Q at all? Okay, quite a few. So that is still going strong. That is kind of our first attempt at jumping into this space, We have an IDE extension. We also have, and it's for multiple different IDEs, we have a command line tool called Amazon QCLI. It's sort of like Claude Code, or anybody try that new, what was it, Copilot? Copilot CLI just came out. Things are moving so quickly. So it's similar to that, but we kept on hearing this kind of same thing is, like, we need to get it more context, and we need to have better results. So we created Kiro. Kiro is the new AI IDE assistant. We have this nice little mascot that's this bouncing, well, in this slides it's a bouncing little ghost. So we actually kind of took a different idea. We weren't going to make this AWS Kiro or Amazon Kiro. It's just Kiro. So we really wanted to open up to all different developers out there, front-end, back-end, DevOps, anybody who wanted to use it. And we took our best learnings internally and externally and created this project with it. We launched a website, kiro.dev. We use Discord for our support. You can use social logins. You don't need anything to do with Amazon to even try this out. But we definitely tried a completely different approach while creating this product, because we as developers wanted a good tool that we can use internally and externally. We've seen with this tool so much, it kind of blew us away, all the feedback we got from it. Within a couple of days, we had to put up a wait list because we had thousands and thousands of people trying to download it. And then people found a way around the wait list. And then we had to figure out ways to stop those people to get around the wait list as well. So it's been really fun seeing the community talk not just about Kiro, but this idea of using spec-driven development with their AI coding agents. And this is in progress. And by the way, if you want to try this out today and you're not on the wait list or haven't tried it at all, stay tuned. I'm going to help you. So some of you probably, any cursor users here? OK, lots, most people. You probably wondered, like, how do I do this without Kiro? This is not a huge pitch for Kiro, but you can do this type of method. Dennis's talk earlier mentioned how he did it with these templates. But there's a few ways. You can essentially tell your agentic IDE, you can use templates, or you can basically say, hey, create a user requirements document. So you can vibe code and be like, create a requirements document based on X. This is the feature that I'm trying to create. And it'll create a document for you. And then you can be like, create a design document. And then based off that requirement. So you'd add the requirements to your context. And then you say, based on those requirements, create a design document. And then it would create that. And then finally, you can have it create the implementation details. And these are the step-by-step tasks that it would need to, that your agentic IDE would need to take to accomplish it. And then you can be like, implement all the things. Start at task 1, end at task 3, and you can do that. The open source community has been amazing. Right after we launched Kiro, there's been this new Spec Kit. Anybody heard of Spec Kit? A few people. So there is a like open source frameworks and not frameworks, open source libraries that have made this process easier, that integrate into different IDEs, that kind of walk you through these steps. Now, I still think with Kiro we've done it really well. I'm a little biased, but you can have other ways to do it with your other IDEs out there. And by the way, someone asked me the other day, so Kiro is based off Visual Studio, you know, most of our favorite IDE, I would say, when I go around. Anybody doesn't use Visual Studio Code? What do you use? Vim. I love Vim too. Long-time Vim user. Yeah, I use the Vim extension in VS Code. Not the same though. So let me show you a little bit the way it looks like, and then I'll have time to do a demo. But it looks like this: spec-driven development. You got this. Here's what it looks like. You'll have a panel on the right-hand side of the terminal, and you'll have two options: vibe, as you expected, is vibe coding back and forth, and then spec, which is that deeper, more way to create those deeper requirements, something that takes a little more in-depth effort. that a lot of people are interested in. It's funny, I don't know if Andre Kaparthi ever knew that this term vibe coding would become so popular after he created that tweet, just in the last year or two. But we're using the word vibe. So how would you do it? Maybe we'd put in a prompt. You don't. The idea here is you don't have to put in like 20 lines here, because through this process, you're going to prompt it, and it's going to create these documents, and then you're going to revise and update them. So in my IDE, in this case Kiro, but build an MCP server that scrapes my local movie website and deploys it to AWS. I put AWS, but this could be Netlify, Cloudflare. Those of you who are Cloudflare Workers fans. Anything you like in there. And then it would work in the background and create a requirements document. This is a little probably hard to see from where you're sitting, but it has an introduction, it has requirements, acceptance criteria, it has user stories basically. And then at this point you can edit this. There's a little refine button in the top right hand corner, so if you find out this is not exactly what you want, you can go in, make changes, click the refine. It's going to add some extra information, and you can go back and forth from here. This might be also the time where you bring in your product manager and be like, hey, do you have any feedback, or project manager, and maybe they can add that to this list. Then there's the design phase. The design phase is we take a look at those user stories, and then we create a document that outlines high level what you're going to do. It might have some ASCII art that explains how the high level architecture is. It might use a mermaid document. Any mermaid document fans? Yep. So that's a nice way to do it. And then once again, you can edit this, update it, and then click refine. Of course, whenever I work with any sort of IDE, it's always good to commit early, commit often, merge back to your branch, make sure you have separate branches, all the good Git version control that we all know and love. You want to do, be especially safe when you're using these toolings, because you have all sorts of things that can go wrong, like inconsistencies, hallucinations, errors, and you can correct those as you continue on. And then finally, you'll get to this implementation phase, which is my favorite part, is when it gives all the different details of what it's going to do to solve this problem. And at this point, it could be very long. It might be a little shorter, but at this point you can go in, update it. You can even go back to the previous steps and click that update tasks button, which would then update these tasks. It's very thorough. It's like an eager intern. It's going to try to do everything it thinks that you should do. It's going to try to create a bunch of tests. It's going to do a bunch of things for you. So you're going to have to guide it. You could be like, do steps 1, check it. Oh, don't do as many tests. Let's go to step 2. Do this. Or maybe you can say, condense it into like 5 steps instead of 20. But it's very thorough. These documents then are now living inside your code base in the .kiro folder. We recommend that you can commit those to your version control system, and then you can have those. Now, if you like to, there's ways of updating those documents, but they're just kind of like a snapshot in time of what you're trying to accomplish. Now, I can't have an AI talk without MCP. Who uses MCP? Almost every talk has mentioned it a little bit. Of course, MCP is the kind of the USB-C of ways of connecting different tools or agents to different tools. The kind of, I stole this from another presentation, but we have like on the left-hand, this left-hand side for you, we have a bunch of agents. We have the middle, which is our MCP server, and then we have our tools. Now, you're probably thinking, what does this have to do with spec-driven development? Have we gone off the rails here? No, I'm going to tie it back in. This is a great way. Of course, Kiro supports MCP, like many of our other favorite tools out here. We support right now standard I/O, but we should be supporting streamable HTTP and some other nice features soon. The whole MCP world is moving very fast, as you know. However, you can integrate your MCP servers with your spec-driven development design. And we've heard this a lot, that people want, they're telling us like, hey, Eric, I'm a developer. I want to use this spec-driven way of creating my app, but I have a product manager who uses Asana. We use ClickUp. We use Monday, or we have all these different systems. How do I get information from there into the specs? Well, obviously, the easiest way is to log into those systems and copy and paste, but there can be a better way. And one of those would be to have the specs pull from an MCP server to your project management system service. Now, for us developers, this is kind of boring. Who cares? We want to get in there and start playing with the code, but this could be possible. And you can do this a few different ways. It also could just grab technical details for your project. Now, we're using Claude Sonnet 4 in the back. We also have some other things we're doing coming soon. But let's imagine that, of course, our Sonnet 4 isn't on the latest, greatest version of Tailwind. I don't know. Anybody try to use Cursor or different agent and it somehow uses Tailwind CSS 3 instead of Tailwind CSS 4? Anybody ever had that happen, or some older library? So I'm like, no, please use Tailwind CSS 4. But then I use my favorite MCP server, Context 7. I don't know if you heard that. It's really, really a great MCP server. It pulls documentation. Then I can use that to grab the latest information on Tailwind. And then you could set rules. We have something called steering files. The same thing like Cursor has rules files. They can be like, hey, anytime you need to go out and find information, use the MCP server to do it. So you can have it go to your MCP. You can set rules files that say, when you're creating specs, make sure you go and grab the correct information using XYZ MCP servers. And so you can grab the project management service MCP. Now, I don't know all the different ones in security. You'll have to look into that, but it is possible. And we are looking at easier ways of doing this. So let me show you a quick demo, because we have a few minutes. So here's what this looks like. This is Curo. Now, if I come back up here, I say, let's create an agent that scrapes my local movie website for the latest movies. And I'm on the spec mode here. Maybe I'll make it a little bigger. And hit enter. Now, it's going to look at all the steering files that I have. And I created these beforehand. This says, always use Context 7 MCP server when looking up documentation or library information. I have MCP servers down here. A lot of them are disabled because I'm an MCP junkie, and I always have 20 of them at all times, and it takes longer to load the app when you have a bunch of different MCP servers. So I have that. And then I have a product, structure, and tech. You can actually have these automatically generated for you. All right, so it actually did it pretty quick. So it created the requirements. So now it has some user stories. Here's the requirements, design, and task list. So here's all the user stories. I'm going to say, move on to design phase. I can also just type in, go for it, or something like that. So now it's going to go to that. And you can see here, it's using that MCP tool to make sure that as it builds the specs, it has the latest information. It's going to grab information from my, in this case, Context 7, but it could also grab information from anywhere else as well. So now it's doing a bunch of research for me, which I really like. And I have the structure here. Here's the structure. And tech. So before I started, I had to generate all these. You actually can just do Curo, generate project steering documents. As I point to the right screen. There'll also be an option if there's no steering documents. Just a quick, while it's working, we do have agent hooks and MCP servers. Agent hooks are like background tasks that you can run that do things for you. Kind of the most common examples is you can have it update your documentation when you do things. You can also have it create test files. I feel like one day we're just going to be just vibe coding and creating specs, and no one's going to ever have to worry about creating tests again, because that's one thing that these agents are really good at, is just creating tests. All right, so it went ahead and created my design document. Let's take a look at that. So here is, come back here, I have design. So here it is. It's a mermaid diagram. You can see that. So let's see what it looks like. I'm going to come here, open in preview. All right, so here it is, design doc. The movie scraper agent will be implemented as strands, agent tool. If you don't know, that's like an agent library created by AWS. And it gave us this nice high-level architecture, what it was going to use. It's going to use Bedrock Agent App. That's another AWS service that helps you deploy agents. It's going to kind of tells me high-level exactly what it's doing here. And as interaction flow, invoke, and web scraper, it's going to use beautiful soup, I think it says in here somewhere. So it gives me everything I need to get started, which is really nice. Now it's asking, the current task list prioritizes core features and marks unit tests as optional. Should we proceed with the current MVP-focused task list and prioritize core features and mark units? So then I could be like going back and forth so it can maybe better create the task list as I expect it. Here's what it came up with. Like set up project dependencies and core structures. This is in Python, so it's using requirements text, and it tells me all the dependencies it's going to use. I could have used this in Node. Maybe that would have been better for this audience. And here's all the way to like step 9, but each step has like 2 or 3 in it. I'll be like, OK, sure, yes. And now it's going to go, perfect, the spec workflow is now complete. I have the requirements document, the design document, implementation plan. And then I could basically say at this point, like start task 1, end at task 2. And then what it's going to do is going to look here at the start tasks and start it. So I'll start with task 1 and complete through task 2. Let me read the spec document. So now it's kind of reading everything again. It's adding everything it needs into the context before it begins. All these files here are already in the context, basically, once you add them. You can also like click this little start task button. So here it is. So now it's telling me it's starting to work on it, which is good. All right, we only have a couple minutes left, so let's jump back into the slides for those who are waiting. So to learn more, you can definitely just Google Spec-driven development, look at the spec kit, look at Kira.dev, check it out. It's free until the end of this month, and then we're going to have a generous free tier in October, so you can try it out. Since it's still on a wait list, though, I have a QR code for you. If you use this QR code, it's going to ask you about 5 questions to take a quick survey. The first 30 people will get a code, and then you can use that to try it Kiro today for free. Thanks. And I got a couple minutes. Go ahead.
Yeah, so I have a quick question regarding like outlining requirements and feeding your agent enough context around the business itself to know what requirements to generate. So, for example, I'm one of the software engineers at DoorDash, and we have a wide variety of in-house business logic, and documentation around that is scattered, God knows where. Right? So, for example, like when you launch an agent and you're planning, it has context based off the code that it has that's contained in, but it might not know exactly why you're doing it, right? For example, let's say I'm building a feature that wants to reduce the time it takes for a customer to order something, right? Reduce friction between like choosing items and checkout. We have, let's say, a metric, right? But it might not know what that metric is. And so how do you feed it that information?
Yeah, if it's like more ambiguous, like you're doing performance updates, it may not, you have to clearly outline it inside, if you're using the spec-driven development approach, inside the requirements and the design document itself. For those type of things, it may be much more difficult, it sounds like, to get that information into the context. If you can somehow summarize what you're trying to do inside a markdown document and add it into the context, that would be my suggestion. You can also, I showed you there's generate steering docs where it even takes large code bases and it puts the most major information and creates 3 different files for you. So having that in the context would help as well. So I think both of those might be the strategy. It might be just take a lot of trial and error to see how it works, like branch it off and then see how it handles different situations like that where it's not a little more ambiguous.
Is my understanding within AWS for your project management service, is that where most of, is that like database sort of storage where all of your like
Yeah, you would. Yeah, it's like Asana or anything else where you just put in different tasks and people can then pull the tasks from it. And every company uses a different strategy. They do the way they do that. I think I'm just about out of time, but I'm going to be outside if you guys need any more questions. Thank you again. What?
Actually, it's a dramatized version of the history of web development, but it will still be brief. So back in the day, when we wanted to create like a Hello World application, all we had was basically C. This is the amount of C code that you needed to make a CGI bin application to display Hello World in the web browser. And in case you're wondering, this is the zoomed out version of the main function, and everything else is just boilerplate. So it wasn't a very pleasant experience. So then, this guy came along. Who knows who this is? This is the inventor of the Perl programming language and goes by the name of Larry Wall. So with Perl, we were able to express our CGI Hello World program a little bit shorter. It looks like a scripting language, which it is, and it's a little bit more concise and a bit more handy. So, but it's still kind of not optimized for the web. So, and then this guy came along. Who knows who that is? This is the inventor of PHP. Goes by the name of Rasmus Leerdorf. So with PHP, we arguably had the first programming language that was particularly designed for web development. So you had like already functions like HTML special characters embedded into the core of the language, and you could also embed like your programming code within an entire HTML document. So, but this is not a talk about programming languages. The reason I mentioned PHP is a program that looked like this back in the day. And this is actually a FTP program. And the way it worked is you took one file, your index PHP, you put it to an FTP server using that ancient program, and then, poof, you got a website. Welcome. So this actually gave birth to the internet giants such as WordPress, Wikipedia, or the Facebook, two of which to this day still run on PHP. So at that time, people start to realize, well, there might be something about that whole internet thing, and software developers started about thinking about software in the context of the web. So what they wanted to do is actually using the languages of their choice, such as Java, or Microsoft.NET, or Ruby, or Python, or Groovy, Haskell, Elixir, or Clojure. So this was actually the time when the first framework wave started. So actually, at that time, a lot of web frameworks, as we called them back then, now, today you would call them server-side generated full-stack frameworks, were like invented, such as Spring, ASP.NET, Rails, Grails, Django, Phoenix, and not to forget, DOS on Dope. So there was only one problem. Our beloved FTP program wouldn't work for deployments. So now what? So things started becoming a bit confusing. But at the end of the day, we ended up with something called Docker. So this way we could use the programming language of our choice, bundle it together with the most crucial parts of the operating system to end up in something that we call the container. And that container we could run basically everywhere. There was again a problem. Those containers were like isolated environments, but you needed to orchestrate them. So you needed to tell them in detail what to actually do. Like, do we have replicas? Do we have, I don't know, scaling groups and something like that? So that eventually led to the invention of Kubernetes. So in Kubernetes is actually like, it can easily become like a behemoth of complexity. So that made developers a little sad. So they started thinking, what if we could just go to the good old days of having those single file deployments? So luckily, AWS came up with a solution for that, which they called AWS Lambda. And the promise was, give me your code, instead of an FTP program, have a little deployment script, and boof, here's your website. So what's the problem with that? The problem is this is good for like talks like this, for quick start, because it just looks good, but real applications need a bit more context. They need databases, files, persistency, authentication, and whatnot. So luckily, AWS wouldn't be AWS if they didn't come up with a solution for that as well. And they named it CDK, Cloud Development Kit. So this actually is what infrastructure as code is. So you had a code file defining all of these services in the programming language of your choice, hit one button, and you have all of your infrastructure deployed to AWS. So we had, for example, IAM roles, Lambda functions, and Lambda function URLs. So what CDK did, or still does, is it mimics the cloud primitives that AWS provides you. And now a question, how many services are there in AWS right now? Yeah, a lot? Any guesses? It's about 250 or something. So it's easy to lose track about them. So, and it does not very well integrate with your application code. So we see what that means in a second. So this talk is only 25 minutes, and we already had the history lesson. So it's time to hurry up to build an Instagram clone. So let us first define how it should look like. So we have a website where you could add a message and upload a picture. You have another website where you could look at those uploaded images. And the moment I can put some message and upload an image here, the moment I hit save, this should get me a success message. And at the same time on the view function, it should like in real time update the posted images. This is kind of the architecture diagram, how we would use that, how we would build that on AWS Serverless. So basically what it does is the user goes to an endpoint, which is a CloudFront distribution, which then has access to an S3 bucket to host the static website, which is the React app that you just saw. And from there, you use an API. This API goes to DynamoDB, stores the messages, goes to another S3 bucket, stores the images. DynamoDB itself has a functionality called streams, so it itself can call back a Lambda to update all those WebSockets. It's a bit complicated, admittedly, but all of these connections that you see here between these services is actually something that those frameworks that I talked about in the beginning did for you. So you lose all of that opinions about how you would stitch together your software. So let's see how that works in action. Let's see if the Wi-Fi works. So I have a code space. See if that works. Works like a charm so far. So there it is. So is the font size large enough for you in the background? Okay, so this is basically what we do now with SST. So we start with like a regular project folder where we have one file for each Lambda function, but we also have like an entire project folder, which somehow isn't loading right now. There it is, which contains an entire Vite project that renders our React app that I just showed you. So this has its own Vite config, and to bring that all together in the root level of the project, we have something like an sst.config.ts, and there, in a similar way as we would do in CDK, we can define the resources that we need. One thing that I want to show you is the static site. Let's see where that is. Like instead of, as you would do with CDK, instead of defining an S3 bucket, then defining the CloudFront distribution, then defining the IAM role between the two, and doing all of that, you could just use SST's built-in static website, point it to a directory, to that directory where we store our project, and it will do all those things for you. And same goes for like the Lambda functions. Our submit function that we use to post those images is just a pointer to a function stored in a file. In this file, the submit handler file, which is the submit TS over here. So then there is another file, sst-env.d.ts, and it says, okay, this file is auto-generated, please do not touch it. But as you can see here, this file is quite empty. We will see what happens when we run our deployment. So I just go and say boonix sst deploy stage dev. Let's see what happens. At least it says deploying. Should do it. Let's give it a few seconds. Okay, while it's doing it, any questions so far?
What providers does SST support?
Okay, very good question. So it does support. So it usually up until the second version, I guess, of SST, it was supporting only AWS because it was built upon CloudFormation. Now with version 3, it is built upon Pulumi. So technically, it supports every provider that either has a Pulumi provider or like a Terraform provider, because Pulumi supports Terraform providers. In practice, it's still very much centered around AWS because it carries all those opinions about it. But you could also, for example, use it very well with Cloudflare Workers.
How's the local development environment, and what services can you run locally for testing?
Most of them. Because in fact, like this is a feature that I don't show because of the time constraint here, but I have a slide on that I don't show it. But what SST does is it can provide the entire infrastructure in AWS. And if you have, for example, a Lambda function, it tunnels back the entire traffic to your local machine so that you can run your code on your local machine, but still use it in the browser as if you were on the AWS infrastructure. So, and that works for even the static website. If we look, for example, at, they have a dev command built in, which does exactly that. Like in the background, it runs the dev server of Wheat, and it can tunnel back all that stuff to you.
Thank you. So is this different compared to Terraform, or is
Yeah, well, again, like technically, SST is a layer on top of Pulumi. Pulumi is kind of a layer on top of Terraform, if you will. What it does, it adds some, so like AWS in and of itself, like has very small building blocks, so they are aiming for 99% of use cases. But there are only so many ways of how you can combine those primitives to make, let's say, a REST API running, right? So what SST does is they're aiming for 80% of the use cases and bring you those opinionated stack that's just easier to reason about, but internally they're just boiling it down to the smaller components.
With the static website construct there, do you get access to like the deeper methods like the ACLs, bucket policy, or like customer managed keys for the S3 buckets that are part of that?
Yeah, it will do everything for you. It will do exactly that. It will set up the S3 buckets, the IAM policies, the CloudFront distribution, and whatnot.
Override that if you want to, like with your own settings?
Yeah, yeah. So basically you can if there is a setting in the underlying Pulumi provider, you can override all those settings.
Given the fact that this is, I mean, you said that it was more tied into AWS, correct? Would it make sense to drop those 2 layers and just go straight to Terraform?
Yeah, well, okay. That is actually the thing I'm waiting for. Because, like, okay, let's pretend it had deployed. What we would see is that this sstenv.d.ts file would get updated. So, and then inside, for example, your Lambda function, you see this Lambda function needs to connect to my DynamoDB table. And the magic source that SST adds here is I can get rid of process.env. Because I can just say import. So now it's done, by the way. Let's see if it works. So, yeah, basically I have a website here. I can, let me open the view tab side by side. And it works. Okay, cool. So what happened behind the scenes? This SST-env got updated. So, and then inside my Lambda function, I can get rid of process.env by saying import resources from SST. And then say, instead of process.env, I can say resource.messages table. So, and this is basically what sets it apart. It integrates into your application code while being deployed. So, and behind, really behind the scenes, they also have a console. And you remember that infrastructure diagram that I just showed you that had like 10, 15 services? In reality, it put out like 70 building blocks to make that all work. So, okay, obviously the Wi-Fi did work, so we don't need the video. So the 2 takeaways here. Like, the first thing is that you just mentioned, the import resource from SST, that is a deep integration into the application code itself. And the other thing is opinions, lots of them. So basically, we've seen all of these things being deployed without us interfering with them. We could override it, yes, but we don't need to. So, and not shown is the local development stuff. Like, you are able to run the Lambda inside AWS, but tunnel back the traffic to your local machine. That's also very cool if you run a local debugger. But the one thing that we haven't talked about is scalability. So there's horizontal scaling for sudden traffic spikes, auto scaling or replicas and stuff like that. And on the other hand, I would have vertical scaling, which would roughly be that picture. Just buy a bigger server. Well, because 80% of companies don't run TV ads. And 80% of companies don't have like a real global audience. What about latency to the edge, latency to the customer? So this is basically a matrix of the interconnection latencies between AWS regions. So, and if you go that way or that way, you see that if you put everything in US East 1, you would be able to serve North America, most of Latin America, and most of Europe within less than 100 milliseconds. So it's really a question if, do you need to get better, really, for the sake of building a distributed system? So, because like when you talk about scalability, this is what people think it is. It's about network and connectivity and distributed system. But in 80% of the use cases, it's not. It's about this. It's about how people collaborate on the software project. So you scale more in people than you have the need to scale technically or for traffic. So I'm not here to tell you that all of this is useless. In fact, there are use cases for microservices or serverless. Here, telltale signs that you might need it. So you have frequent merge commits to your monolith. might be a good time to split it up to microservices to have teams working on individual components. If you need to scale from tens of people to hundreds of people, or even higher in a short amount of time, or if you really, really have that global user base in, I don't know, Middle East, Asia Pacific, or what else, or if you just want to ride the latest trend, well, that actually is a red flag. Don't do it for the sake of doing it. Please do not. So there are still open questions that we can't cover in the last 3 minutes. So one of which is, how will the boundaries between developers and operators like merge or will blur over time? Because that's what DevOps originally promised. I had a conversation with Dax Rath, who is actually one of the co-founders of SST on my podcast. So if that's a conversation that you might want to jump into if you want to learn more about that. Sorry. And the other question is, how can we migrate from, like, let's say, a monolith to a microservices architecture? I had a great conversation with some guy from AWS by the name of Luca Mezzalira, like just the other week. So where we go deep into that. You will find those episodes on my podcast at buzz.fm. So now we have time for a little commercial break. Is anyone using Python? Oh, very cool. So Stelvio is an open source project that I'm working on together with another guy. It's basically what SST does for JavaScript, but it does it for Python. Check it out if you are using Python, if you want to do something with it. It's a very early stage, where we got a couple of things running, including AWS DynamoDB and stuff like that. So I think 2 weeks ago we released also like a static website component. So it's stelvio.dev. So, and if you take home only 2 things out of that talk, that would be, in 80% of the use cases, you scale more in people than you have a need to scale in traffic. And the other thing is, in 80% of the time, it is better to have a framework that has opinions that you can use than to build upon those cloud primitives for yourselves. Any questions?
Can you hear SST is like basically infrastructure as code, but point the handlers to individual Python files to like leverage both?
Sorry, I didn't get that.
With SST, can you use that as your infrastructure as code, and then for the handlers on those individual lambdas, point that out to Python handlers?
Well, actually, it might be technically possible, but I never tried it. And it's just not designed for that, because it's designed for like TypeScript/JavaScript.
I just wanted to add about the scaling for traffic. I think EC2 now gives you a machine with terabytes of RAM.
Yeah. That's a lot of RAM. That's a lot of RAM. So then the machine is going to ask you a question. No, just kidding. But seriously, we are at a conference with a $49 ticket, so go buy some merch, because all of that's going to charity as well. Visit the sponsor booth, and please leave a feedback like on the conference overall and on that talk. Thank you. Well, 3 seconds left.
Unmute.
Yeah, hello, 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 hello.
Yes.
It's good? They're picking me up?
Yep.
Cool.
Yep.
Cool, cool, cool. Awesome, thank you. Sweet. Does this still, if I put, let me test this real quick. If I just drop this in my back pocket, it doesn't create any interference. Nope.
I don't think so.
Looks good. Rock and roll, man. Rock and roll. Cool. I'm ready to rock whenever you are. Cool. All right. Hi. Thank you all for coming to my talk. This is JavaScript for the rest of us. I want to talk a little bit about some alternative solutions to modern front-end frameworks that help you be a little more productive along the way. So first things first, to know who the rest of us are, to know who I am. My name is Jacob D'Addario. I'm a senior software engineer over at a small firm in Grapevine called Vent Technology. We help with accounting automation, and I write Ruby on Rails for an internal tool for the company. If you need any accounting automation services, we're happy to help you. But more importantly, oh yes, even more importantly, I'm recently married, so there's some lovely pictures. Thank you. Yes, of my friends and beautiful wife. But enough about me. Let's talk about this guy. This is the Shad CN guy. Nameless, faceless. Evidently, he works for Vercel now. His profile image is a cartoon character. Sort of an enigmatic figure. but he is the core maintainer and creator of the ShadCN library. You all have probably heard of it. It is sort of like a web primitive solution for React. Everything you need, readily styled, adjustable and themable with Tailwind CSS, fully accessible, keyboard navigation. I mean, just look at it. You get this button, you get the flyout drop-down menu, you can go nested in it. Like I said, keyboard, ARIA compliant, the whole 9 yards. Done, right? Like the talk's over. I think this is all we need. But maybe not, because when you reach for that solution and you start going that front-end framework path, you're not quite done when you just start dropping in the components. Now you need to wire up the forms. So let's take a closer look at it. You know, you can't submit forms like you can with the normal form implementation when you're using React. So now you got to wire up some state. You have some state management there. You need to wire up a change handler, right? You need to bind the state to the inputs. You have to bind the value to the inputs because the DOM is redrawn every single time. You know, if you just have a standard web page, the inputs can remember what their value is, but not when you're redrawing every single time your state changes. So now you have to bind all that. And you can't submit forms, right? So now you have to write your own submit handler. You have to pull in Axios or write your own API client. You're doing a lot here, and you still don't have things like real-time validation or error handling. So maybe you reach for a different solution, right? This is still a lot of code, but now we've pulled in React hook form. This is a pretty common custom form hook that allows you to ease the process of making forms with React. If we zoom in a little bit, we can see we get some abstractions here. We have this new register method that comes in. We have a special handle submit that we need to implement. But you know, the state's contained in one place. We now have error handling built in. If you look at some of those input tags, you can see us binding them with the register method. You can see us binding them to certain names in the state. You get some validations, like you can require fields. Now we're getting a little more functionality. We've introduced some indirection, but you know, we're most of the way there yet, or now. But are we done? No, because now we need to do some of this, right? This is the Swagger UI. This is how a lot of people document their APIs these days. Because now you have to hit your backend. You haven't even implemented the backend yet, right? And you probably have two different teams. You have a front end and a back end team, so you need to communicate between the two of them. So now you're spinning up this documentation that everyone loves and loves to maintain because you have to do governance, right? What if more people become dependent on your API? Now you have to worry about versioning. And maybe we should have used Fast API. I don't know. That would have auto-generated it. But I've got this new LLM thing that uses JSON schema and generates. It's great, guys. It's great. And now you're doing this, right? You're in kind of like Zoom purgatory with these horrifying AI-generated faces. They're all frowning. The buttons are in the wrong place. And you need to ask 3 people where the contact form is. It was a contact form. Didn't we know how to do this? Isn't there a better solution? Well, the Rails ecosystem thinks so, and they've tried for a long time, but I think they've finally landed on a good solution. And that solution is called Hotwire. It's a suite of 3 libraries. Today we're going to talk about 2. The 3 libraries are called Turbo, Stimulus, and Turbo Native. We're not going to discuss Turbo Native today. One of the questions you may already have is like, hey man, if you're not using an API, how do you do mobile applications? Turbo Native is the solution to that problem. It uses web views and allows you to layer on first-class like iOS and Android primitives over top of it to get that kind of like native experience. We're not going to focus on that today. I'm happy to talk about it with you if you'd like to, though. But first, we're going to talk about Turbo. Can we simplify page navigation, right? Can we get that SPA feel without having to introduce like a specialized router? Can I just visit pages and have it not be kind of bad? So the first part we're going to talk about is Turbo Drive, and we're going to take a closer look at these 2 videos here in a second. Turbo Drive replaces the way that page navigation works in your application, right? So this is a navigation without Drive. Perfect, beautiful, 2005, the page snaps. You have massive layout shift. The user doesn't know what's happening when the page is loading in, right? We all remember websites like this, mostly. I was 8 in 2005, so I kind of vaguely remember. But we all remember the days of like web pages coming in 1 chunk at a time. This isn't a good experience. So what does Drive do to solve this problem? Drive does a few things. By the way, all of these requests are artificially slowed down just so we can see the effect of things. Firstly, with Drive, when you issue a page request, you don't see that page snap. And instead, if the request takes more than 250 milliseconds, you see a loading bar pop in. So you don't have like this effect where you navigate the page and it's slow and you just like jump to a blank white canvas. That's obviously a bad experience. This prevents that and gives them a nice loading animation. The next thing it does is it pulls from a navigation cache. You can disable this because it kind of has some rough edges. It can create some weird UXs if you're not careful. But for demonstration purposes, it's included here. And you can see, I navigate to that page right away, and it's still loading, but we actually jump to the new page instantly. And that's because that page was in the navigation cache. And the last thing it does is it just swaps your body in and out, right? That's why there's no layout shift. We're not hurting our Lighthouse score with this, because while we're waiting for the thing to load, we get the whole document in, and only when the whole document is in, we swap out the body. And so you get this SPA-like navigation. We have a web app that looks like what users expect in a modern web app without having to create an entire artificial routing layer, right? So next up is turbo frames. What do turbo frames do? And we'll look a little closer at this video in a second. Turbo frames do partial page decomposition. Now you may be asking, well, I don't know why I'd want to like decompose my my page into separately navigable elements, and that's a reasonable concern. I have a similar suspicion, but there's one use case that they're really good for, and that's lazy loading. So here I've enabled one of our Hotwire dev tools that shows us where turbo frames are on the page, and that's that sort of cyan dashed outline. And I'm showing what that lazy loading looks like. So what's happening here is this is a little like demo app I built. I'm navigating to an organization show page, but there's a sub-resource that's underneath it, right? It's a list of members. And for whatever reason, let's say it's particularly slow, so I want to lazy load it. How do I do that with turbo frames? I create a frame region in the page. And so on first load, that turbo frame just has the skeleton loader. And when it mounts on the page, this custom element initiates a web request to a second endpoint, which returns the remainder of the data. So how does this work? This is the network tab. And don't worry about the specifics. I know it's completely unreadable. I've done the old social media red arrow thing. There's 2 requests kicking off. So on the very left-hand side, you can actually see the initial page load, right? So that's when I'm saying, take me to organization ID 6 or UUID, whatever. And then that's when we see the page snap in, and it has that skeleton loader. That's what comes with the first page load. But once that page is loaded, the turbo frame element mounts onto the page, and it sees that it has something in its source attribute. That's a key to it, that it's been navigated, and it does that to initiate a lazy loading request. And that's that second request we see there. And so the response that I have included in this image is what we actually get back from the server. This is another full page navigation. We just returned a brand new body. And in that body, we have a turbo frame element with the ID memberships tab. So the way that works is whenever Turbo gets a response back that has a frame in it, it looks for a frame on the existing page that has a matching ID. And if it does have a matching ID, it just swaps it out. And so that's what happens here, right? And for some reason, Keynote doesn't want to play this if I only go back 1 slide, so that's why I keep going back 2. That's what's happening here. The frame initially has that skeleton loader. It makes the request. It swaps in the new content, which is the data the user actually wants to see. And we've still written 0 lines of JavaScript. This is all built into the application. All I had to do was build my Ruby on Rails app or any app, Turbo and Stimulus, and the whole Hotwire stack is framework agnostic. All I did was build my web application like we did in 2005, and I got this sort of like smooth page transition. I got lazy loading, the sort of stuff that we associate with modern web apps for 0 lines of JavaScript. So next we have Turbo Streams. We're going to look closer at this demo right here. What's happening? So I'm in a authentication page, and I'm typing in the credentials for a test user. And then when I go ahead and submit it, something curious happens. I get a modal that says, hey, your user is not confirmed. Click this button to resend the email, or hit OK to close it. Well, that's kind of strange if you think about it, right? Because that's not a page navigation, right? I'm actually making a modal appear. That seems like JavaScript to me. And that doesn't make sense, because in order to know that a user isn't confirmed, We need to phone home to the server. What's happening? How am I triggering this? It's server trigger JavaScript. So what happens whenever you make a stream request is you get an HTML document back. In this case, it's another custom element that comes with Turbo called a Turbo Stream. That Turbo Stream has two things on it. It has an action, which tells Turbo which pre-canned JavaScript action it wants to take, and it has the data necessary to execute that action. So in this case, we can see it says action append, so we're adding something, and then the other data that's needed is a target. So the target in this case is telling it, go find an element with ID root, and then it uses the template tag that it ships to take everything in that template tag and append it to the root element that we've targeted. And so in this circumstance, what I'm doing is I've created a modal component, right, just with vanilla JavaScript, that I'm appending in the open state to the root element. And that's taking on and creating a portal like we would in React, locking scroll, hijacking focus. And so you have that sort of like portal-esque experience without needing to write any JavaScript. Again, this is pre-canned. Now, some of you may be familiar with the Ruby on Rails ecosystem. If you are, I want to clarify something. Streams are not this. If you know what this is the old Rails UJS technique. Coming from an era of CoffeeScript in like 2013, you know, it was pretty poor timing. Like a lot of the Rails JavaScript tooling came out right before Facebook launched React and like massively changed the way we did things. Angular was gaining in popularity too, but my understanding is React was much more popular. So they did this unobtrusive JavaScript stuff. What this was pretty crazy. What it was is you would have a .js.erb template, and if you responded with this, it would literally inject it into a script tag on your page to execute. Now, that's super dangerous, which is why they don't do it anymore. Basically, all modern content security policies don't allow you to do that. Executing unvetted content in a script tag is bad practice. So we no longer do this. This is not this. Trying to introduce metaprogramming into a place that doesn't belong, the land of untrusted input, was probably a bad idea. So streams are not that. They're pre-canned actions. There's 7 actions that come standard, so that JavaScript is never changing. It's always trusted and safe. It's just the stream element that you submit sort of as an argument that changes the behavior. And we have still written 0 custom lines of JavaScript. I have not had to open a .js file to do any of this. But sometimes you need to write JavaScript. So what do you do in that circumstance, right? That's what you use Stimulus for. You organize your JavaScript with Stimulus. It's all vanilla JS. There's no virtual DOM. There's no custom domain languages. But it's a way to organize that vanilla JS that makes things a little more sane. So let's look at the problem. This is an example of like an old jQuery file that you would find in many static sites and Ruby on Rails applications circa like 2015. And there's a couple problems with there. One, state management is like a disaster. You can see here at the top, that's how you store your state. You just open an object, you start checking stuff in it. You can do things with data attributes too, but those pose their own problems, because if you start putting things in data attributes, you have to figure out like which elements are holding which state. Another thing is selecting elements is fragile and unorganized, right? You just kind of have to begin every single thing either with like a jQuery lookup or find query selector, which has its own quirks if you want to stay away from jQuery. Similarly, like a lot of this stuff is cached. So what happens if I start introducing new elements into the page? How do I like worry about refreshing that? And then finally, you end up with this event listener chaos, right? Especially if you're not very good about splitting your JavaScript assets. You may, like, on every request, be trying to select things that don't exist. And like, what if you're using too general of a selector? In this case, this thing's trying to select on .button. That's really generic. You can get yourself into all kinds of weird circumstances. And finally, like, there's no opinionated way offered on how to factor this code, right? So that's why you usually end up with these giant, crazy jQuery files, because no one is given a good guide on how to put those in their own and proper place. These are the problems that Stimulus solves. So let's look at this. This is the outline of a controller, and you can see a few things. So there's some static definitions at the top, and we'll talk about those in a moment. And then just a set of methods. I know we're using the JavaScript class structure, which people don't love. But as a Ruby developer, I love OOP, so it feels natural to me. And what this does is it provides also a reasonable place for you to factor your code into. In this case, this is a list box controller, right? List box are those fancy styled selects that don't use the OS native like select input. So this is what I use to implement a list box in that demo application. And everything for that list box is contained here. There is a natural place to factor that code into. So let's talk about the parts of it. First, we have the values API. So you see I have a static definition for values. It's an object that declares the different values in it and their types. And it puts all the state for that piece of code in one place. And it gives you accessors on the class itself. And it also allows you to do things like write callbacks, right? So you could think of those sort of as custom hooks. When you write custom hooks in React, you say use state. You're almost always wrapping use state and then adding some additional logic. This is sort of the same way, right? When I set selected, I want to also trigger these other side effects. And then there down at the bottom, you can see this is also like, now I can just reach for my state with a normal method invocation. It's always up to date. It's always stored in the DOM. It's safe, easy. It looks like OOP. Next, we have the targets API. One of the most annoying things in JavaScript is like actually selecting elements. Targets handles that. So here we can see another static declaration of targets, which includes an array of strings. This tells you what all your targets are called, and it creates a bunch of accessors for you. It will automatically update that list. You don't have to worry about stale references, right? If you start adding in new elements that have that target on them, they'll always be included in the list. And it also allows you to put lifecycle callbacks on those. I don't know if I think that's a good idea, but you can if you want. You can add custom code to run whenever an element is added. And then again, now I don't have to worry about query selector. I don't have to worry about figuring out where I stored the reference. I can just call this.template target, and I will always get my template element for when I want to insert that little like list box drop down into the page. And you can set this with the controller name dash target, and then values was controller name, value, value. And then finally, we have the actions API, right? This is our event listener management, all handled for us automatically. So they're always auto-registered. They're always unmounted whenever the element goes away. You don't have to worry about them. You can set them with data action. So for instance, on my list box, if I want to change the selected element when something in the list is selected, I would say click, list box, # change. And that registers that event listener for you. And now I can organize all of those event listener callbacks as methods within my controller. And so just to give you an idea, this is all just Stimulus and Turbo. There's no React, there's no Vue, there's no Angular. This is just vanilla JavaScript. And I've got modals popping up. I have modals coming back from the server. I have keyboard accessibility, appropriate ARIA markup. I got portals on top of portals. The stacking context works correctly, and I didn't have to write any front-end code for this. So where does this fall short? Funny enough, this was supposed to originally be the topic of this talk, but then I realized, like, with the time I have, I probably need to explain what it is first before talking about some of the shortcomings. But I've been really kind of limit testing this technique, both at work and at home over the past year, and I've come to the conclusion on a few things. Firstly, complex template management is obviously a nightmare. That's pretty obvious, right? When you start thinking of the way that you structure React components, where you can make different parts of your component appear depending on internal state, like, you can't do that. You can't, if you don't have a hydrated DOM, that's not something you can do. Now, you can use like the native HTML template tags, but that's not going to fly for complex state management. And so like a great example of this is a date picker. You can't put every single month in a template tag. That's psychotic. You need to probably reach for something like React for that, or a library, like if you want to use flat picker or something like that. The other thing is I had to write a portal implementation to make those like modals and stuff work. That was a nightmare because there's no shadow DOM, right? So now I have to relay events back and forth. That's crazy. I kind of regretted doing it, but there's more on this in a moment because actually this is more of a solved problem than it was when I started. Another thing that it struggles with is atypical form designs, right? Auto-saving forms are just annoying. You can do a couple things, right? You can do programmatic form submissions, or if you want to be like really fancy, you can just hide a button and programmatically click it. Both are not great solutions. It creates really weird user experiences because we can't really intercede when a form request is happening, where it becomes really difficult. Whereas with React components, we're able to drop our async await, notation on there and hold up before we do navigations. So auto-saving forms have some problems. Nested forms are also a nightmare. Form-encoded responses are great. I think they're super easy to parse out, especially when you already have a web framework like Rails that helps you with that. The problem comes in when you're like, well, I've got this thing nested 5 layers deep arbitrarily, so now I have to do tree traversal. It's like it becomes crazy. You don't get to flatten out the structure and just send it to the API like you would with React. So I'll tell you personally, anytime I'm writing a nested form in the future, I'm looking to mount React onto the page. And then the last thing is any insane wizard setup that's impractical to persist to the DB. I'm a big proponent of just persisting those intermediate results, right? It creates safety for you if you're going to do a multi-step form to write it to the DB. You don't risk data loss at that point. And you're probably going to do it anyway so that people can resume filling out the form. But not every wizard is compatible with that design. So if you need to hold intermediate state on a complex form in the front end, you can't really do that very easily with this setup. And finally, applications that are true applications. So think Miro, Canva, this sort of thing's not possible. It doesn't comply with the conventional web, right? We sort of had to contort the web spec to make those sorts of things possible, which is also why those companies make money. They wrote an incredibly complex application that you can't do with just web native tools. Now, I said I was going to come back to this thing on portals. So when I began this, I began sort of noodling on this at home maybe last December. And I spent all this time implementing vanilla JavaScript portals, and it was crazy. Because you have to worry about your stacking context and things like that. Well, right around the time I was wrapping this up, the Tailwind company released something really cool. They're calling it Tailwind Elements. These are all custom elements like turbo frames and streams that have all of this functionality built into it in an unstyled way that you can just drop in. It's like there's a real first-class list box, stylable select in HTML. All you have to do is say L-listbox, and you get all of that behavior for free. And they did it using the popover and dialog elements. These have actually been supported by a majority of browsers for 2 to 3 years now. They add true top layer support, so you don't have to simulate it with React portals or vanilla JavaScript portals. And I kind of wrote them off because it's a lot of the W3 spec stuff is kind of hard to work with. But the guys at Tailwind are amazing, and they made them work. And you can just drop them in, no JavaScript added. You get instantly accessible dialogues, list boxes, alerts, whatever you want. So yeah, that's my talk. We have found we're able to move a lot quicker when we stick to these one-person verticals, not separating UI from backend, being able to implement features all in one shot, not separating people across tech stacks. It served us well at Venn. It served me well on my personal projects. I'm a big believer in it. It has its limitations, but I know where to reach for it now. So hopefully I taught you all a little bit about that. Thank you for listening. I'm at Jacob D'Addario on GitHub, Twitter. If you'd like any other contact info, please feel free to ask me. But thank you for coming.
Yeah.
Can you talk and see?
Testing, 1, 2, 3, test.
Okay, that works.
All right, can everybody hear me? Now I can't scream. But yeah, I'll give it another minute or so. We'll flow in. It's awesome. It's a packed house. I like it. I wasn't sure if anybody was going to show up for this topic, but then I started talking with people, and then they're like, yeah. So, okay, cool. Just a bunch of nerds. That is who we are. So I think we're ready to roll? All right. So how many people here got into software development because of games, like tied into games somehow? Like you wanted to write a game, you wanted to pirate a game, whatever. So like, right, so a lot of you, well, that's exactly what the story was with me. The exact same thing, like I just got into this programming thing, and I'm going to tell you a little bit about my journey where I tried to be a game developer in the 90s and it didn't work, and then came back to it years later, but I never got rid of the programming part, right? Because that was the fun stuff. So my name's Jeremy Morgan. I know some of you here, but most of you I don't. I'm a software engineer, generally, DevOps engineer, and most recently I'm an instructor. So about 5 years ago, I did a pivot from day-to-day DevOps engineer into an instructor role. And you might notice that none of that says game developer, because I am not a game developer. And that's pretty much why I'm showing this. I'm just a software engineer geek guy, but I love retro games. And I recently rediscovered these things, and then I dug into building them. So in this does this talk, I want to talk everybody into becoming game developers and building your own game, like maybe even this weekend. And I think if I show you the basics here, I think at least half of you will probably go back and look at it and be like, this is so cool, this is so easy. So that's my whole goal, is like, why retro games? Why are those cool? And why now? That's going to be pretty much my talk. So they say, I don't know where I read this, but they say somebody's favorite video game is usually the one that was released when they were 12 years old, or that they played when they were 12, like on average. That's your favorite console, that's your favorite game. For me, that's absolutely true. I was 12 years old in the late 1900s, so we had the Atari 2600. Yeah, I don't know if anybody remembers that. Yeah, that was pretty awesome. That was a great console. My favorite, the original 8-bit NES, so I loved it. Sega Genesis. TurboGrafx 16, anybody? See, nobody, I don't even remember seeing one of those, but I remember seeing the commercials all the time. And so I wanted to make games when I was playing these types of things, but there was just no way to do it. I mean, you just couldn't. They're big companies building with licensing and things like that, but you could for a PC 286, which would be the other game console of when I was 12 years old. And so at one point, a friend of mine and we were talking about building games, both of us. We're like, we want to build games. We really want to do it. And we found this Sony NetYaroze thing. And it was a Sony PlayStation, but it had all these different ports on it. It had an SDK with it. It had all this cool stuff. So we're like, yeah, we're going to get that. It was like $750, which back then, as a teenager in the 90s, that was a lot of money. When we did come up with the money. And then by the time we contacted Sony, they're like, yeah, we're not doing that program anymore. So we're like, oh, I guess we're not going to be famous PlayStation developers after all. So then I got into the C++ game, because that was the only other option for an independent single person to do development. I bought this book, Teach Yourself Game Programming in 21 Days, and I went cover to cover through this thing. Some of y'all might recognize this. This is a pretty popular book at the time. It took me far longer than 21 days, I'll admit. Nowhere near 21 days, but I hammered on this thing for like a year building these things, and we were building it in C++ using mode 13H. It was a pain in the butt. I also bought this book, giant graphics book, and this is written by somebody that's like a graphics genius, you know, and he helped with the Quake engine, several cool graphics things, and I read that, and this was kind of like a brief history of time for me. I read that book too, and I understood a small percentage of it. That's exactly how I feel about the graphics programming black book. I learned stuff, I didn't understand it fully. So back then, in the 90s, when I first started, what were the barriers to building your own games? Well, you had to know C++ really well. I learned C++, but I wouldn't say I know it very well, even to this day. But you have to know C++ really well. Also I/O, memory, VGA graphics. So back then, you used to have to draw a screen. That's what this little demonstration is you would have, so mode 13H is 320 by 240, 256 colors, which today we think about that and it's like, that's ridiculous. But you would take that and you would actually draw screens, and you would put screens into a screen buffer, you know, and you'd have to load like 10 of them into this pipeline, and you had to know how memory works, how VGA cards work, how video memory, which at the time, I think 1 megabyte video memory on the video card that I was using. So it was very tricky. You had to have an expensive compiler, so that C++ compiler that comes with the 21 Days book, pretty good. It was like a minimalized MSVC, worked okay, but if you wanted to really build games, you're going to have to buy some thousands of dollars worth of Borland products or MSVC, the good kind, and you also have to purchase expensive libraries and SDKs. So if you wanted to do a 3D game back then, you could either write it yourself, take 5 years to do it, put it together, learn assembly language, all this, or you could pay a whole bunch of money to people who would give you that. And so the reason I bring this up is not to be a big whiner, but it's because it's so much better today. So before, you'd have an idea for a video game. You're like, I'm going to make this video game, throw a whole bunch of money at it, throw a whole bunch of time at it, get frustrated like crazy, and then you would have a game 6 months later, a year later, right? But now, today, in 2025, we have Phaser, which is what I'm going to talk about here, and a million other libraries. So what are the barriers now? What do you need to do now? Well, you need to know some JavaScript. That's cool. I don't even really know JavaScript that well. I'm a back-end developer, And I honestly am not super strong with the DOM and JavaScript and all that, and I'm able to write games all over. So you need to know nothing about hardware. So I talked about all that, like memory addressing and stuff. You don't need to know anything about that. You don't need to know interrupts and IRQs for controllers. None of it. And you have cheap or free developer tools, which I'm going to show you as a part of this. And I got to speed it up here, I can see. Cheap or free libraries and SDKs. So there are tons of libraries out there, tons of SDKs, and I'll show you itch.io is one of them that I spent a lot of time in. It's a silly name for a website, but it has a bunch of cool stuff on there. So now you just get an idea, you spend a little bit of time, you're a happy developer because it's actually a really nice development experience, and you have a game in a weekend. That's the promise. Build a game in a weekend. Absolutely possible. If you can open a browser, you can make a game. So I'm going to show you some of the basics of just a very, very bare bones phaser game. This one is called Catch the Apples. And what I did is I did a series of YouTube videos. So I did 3 YouTube videos where it's like, let's build a video game from scratch, a 2-dimensional retro style game from scratch. And I tried to make it just as bare bones as I could. And if you look at this, you've got a config file. This is an object. Can everybody see the screen, by the way? Oh. Okay, let's see. Can I drag it over there? Yeah, I can drag it over there and then point, I guess. So there's a config object here. That's pretty easy to figure out. You've got type phaser, and there's different types of phaser games. Game styles that you do. This is just auto, so I don't know. I've always put it on auto, and it figures out what you need to do. The width and height, 800 by 600, right? Pretty standard. And then there's physics. There's arcade physics, and there's realistic physics. Arcade physics are super easy to work with, so that's generally what I use. And then some other settings in our scenes. Yeah. Let's see. We'll close the Explorer. There we go. So you've got that config object here, and then you just create a new game instance. And then there's 3 main functions that you see here. And like I said, this is very bare bones, a big, huge phaser game. I'll show you an example of that. But this is very bare bones, and it has preload, which is pretty easy to figure out, right? This is the stuff that you want to load up and keep in storage to use. You have create function. That's run one time, and that's when the scene starts. This game is only one scene, so it's just, you know, create function is called one time, and then update is called 60 times a second. So I'll show you what a preload looks like. Pretty straightforward, right? So I have a background. I created some stuff on my iPad with a little pixel art background. Created a pail and an apple. And so I'm going to make an apple fall from the sky, and we try to catch it with a pail. These are all loaded up under background, player, and apple. And then during create, this is the one that's run one time when the game starts. It'll add in my background image, position it at the center of the screen. We're going to replace rectangle with sprite. I left that comment in there because earlier in the video I made it just a rectangle. But so this is a sprite, and it's player. So it's just loading up that little graphics file as a sprite. And then there's an apple sprite. And then we have enable physics. And this is basically just says anything in the game that moves has to have physics assigned to it. And so it's very abstracted, very much in the background, but it does things like gravity, collision detection, all that kind of stuff. And that's all the code it takes to make something a playable, movable object. And then we create the player controls here, and then just a few little, score, item speed for how fast they're going to fall. And then I add a little score text at the top that says score equals 0. Now, update here is called 60 times a second. So this is the one that just constantly loops all the time, over and over and over. This is the one where you make a mistake in this function, you know it immediately, because it's whatever bad it does it fast and hard. And yeah, you can overload consoles, or not console, but overload your browser, memory, and all kinds of fun stuff. So here, we're just constantly checking for this threshold to see where the score is. I have this little score increase, so when your score goes up, the apples fall faster. And all of that is done in this simple little function here. Move player left, move player right. If you ever did anything with C#, C++, or anything regarding controls and keyboard bindings and stuff, this is so brilliantly easy and simple. And like, this is just like, move the player 5 pixels as long as that button is held down. So this is the amount of code that you have to write to put these things together. And I reset the item, so when the apple falls to the bottom of the screen, I just reset it and put it in a random spot. And then we check for overlap, and this is collision detection. We're just basically seeing, does the apple hit the bucket? If it does, we'll increase the score, and we'll reset, and we'll drop another one from the top. And this is really all the code for this game, which I'll start up. Now, I'm not going to say it's a super impressive game, but it is a shockingly low amount of code, in my opinion. Fire this thing up. Sorry, it is a little awkward over on the screen. And where did that browser go? Oh, here it is. Okay. So I'll load this up. Does this feel like pretty easy stuff? Am I crazy, or is this like a small amount of code for a game? It is cool. And so I'll refresh it because they're going wild there. And yeah, you move this back and forth and just try to catch the apples. You can see the apple speed obviously is a little high. So gravity times 10. But yeah. So what's really cool about Phaser is just it abstracts so many things. Like I said, with the keyboard controls, things like that, it abstracts so much. I'm going to go into some tools here. No, just a little bit so I can see this. So you can see some of the tools that you use. Obviously, Visual Studio Code, right? That's pretty much a standard for me for I don't know how many years. But that's how I prefer to write it. But I'll show you in a minute. There's another one. I'm saving it for the end, right? There's tools like this Pixelator, or Piskel is one of them. You can take these tools and just draw the little pixel art. Like I drew this bucket and the apples. And then I used, I think, Midjourney to do the background. So if you're not an artist, like me, I'm not an artist. But if you're not, you could still get this, or you can go to itch.io, which I'll bring up. And here's another one that I wanted to show. So I have a more complex game that I put together. And in there, in the levels, I don't know if I can see this. This is something called tiled, where it takes that entire screen that you were looking at earlier. And this is for a different game, but it takes this entire screen, and you can just drag over these little bitmaps, put them into place, and then export this as JSON. It makes this big, huge, unreadable array, but it's like super easy, and this thing was $10, I think. Something like that. It's like ridiculously cheap. But this is one of the tools that I like to use a lot because I can just drag these things over, and like I said, I can just export it. I'll show you what it looks like exported. We'll go to the more complex game real quick. And this one is called Totally Awesome. And this is one I built a few years ago on a live stream. And so you can see with this one, it's far more complex than the whole single page thing that I had before. I've got collision manager, enemy manager, all this stuff. And have all my assets. And then here's like terrain.json. This is what that tiled program generates. Like, nobody's going to want to write this by hand, right? So this tiled program is just amazing. And I think most people probably would too. I did start by doing these by hand and sort of putting them together. I'm like, this is terrible. And then I found tiled. I was like, all right, so that's cool. So tiled is one of the really good ones. There's the good pixel editors. And then there's something that, so I built this game in Visual Studio Code with no AI and all this stuff years ago. And then they came out with the Phaser editor. I think this thing is like $150 a year, something like that. But this thing is really cool. I'll admit I haven't gotten into using it quite as much as I should. But when I do, there's all kinds of cool stuff. So you have things where you can do basic JavaScript, Byte, Webpack. They have starter packs here where you can do like simple A Day at the Beach, Angry Balls, Flappy Chicken. There's some good names here, right? Sunnyland Forest. And these are all just pre-made games that you can just use as a template. And so you could start that up, and then you can go in and modify all your bitmaps and do all your stuff. And it's really cool. It also has things like Angular, Bun, et cetera. Just a whole bunch of cool stuff. So like I haven't really dug into it too much, but I did purchase it, and I did use it, and I'm probably going to use it on my next one. Now, one of the things, so I tried to keep AI as much out of this talk as I could, because that's all I talk about these days is AI, like most everybody else. But we're going to skip through this because we don't have time. But I guess I could cover this. Yeah, I could cover this really quick. So what we just looked at, there's 4 core pieces to every Phaser game and app. There's a config. That's that simple basic JS object. There's scenes, which we only had one scene there. But if you think of it, scenes as like routes or pages. That's all they are. There's the beginning screen, level 1, level 2, level 3, ending, et cetera. There's game objects, which I showed you those sprites. Things like the bucket, the apple, the walking person. And then there's just systems. And systems is mostly all the background stuff that you choose it, and it works on its own, like the physics and things like that. You don't really have to do a lot of things with physics and collision detection and all that. It's just a line of code, and that's all in the systems part of it. And then every 60 seconds, it scans for input. So it looks for mouse movements or keyboard, whichever you decide, or joystick. Then it applies physics to everything. So it takes all the objects and says, this one needs to do this and this. And then it does an update. Obviously, it says, these are where everybody's at. This is what's happening. Is the apple in the bucket? Yes or no? And then, of course, the renderer that spits it on the screen. Sure. Oh, no, I made a mistake there. Yeah, every 60 seconds. OK, 60 times a second. Yeah. So, yeah, it's not that slow. If it's once every 60 seconds, then yeah, you're going slow. So I did this. So I do want to talk about this vibe coding and JavaScript games. So I decided, this is not a Phaser game, by the way. So I've done this stuff with Phaser. I've built several games. It's really awesome. And then I decided I want to do a 3D racing game because I love racing and I think it would be fun. So I sat down with, I think, Claude Code mostly. Had these huge, long prompts. And I'm like, I want to build this 3D racing game that does all this cool stuff. And this is what it came out with. And I would say it probably took me about an hour to have something playable. And I started to dig in after that, right? And I'm like, I don't know 3JS. Hardly at all. I know it better now, but I didn't at the time. I started digging in and fighting with it and just fighting and fighting and fighting to where eventually, I'm not going to say how many hours I spent, but I basically gutted out the whole code part of it. And the only thing AI generated is the art because I'm not an artist, right? So and the reason I'm telling you that is because I think that we're going to see that a lot with AI stuff. There's that 80-20 problem that people talk about. Like you get 80% of the way with AI. And in this case, I'm truly vibe coding because I don't know 3JS, so I really was just like, oh, now it needs this, and now it needs this. And I think it's great. I think vibe coding is awesome, especially for proof of concept, quick stuff. And so, if you have a game idea, you can do it, but don't expect to make this fully functional, playable game because I fought it like you wouldn't believe. I had cars flying up and down and all over. And yeah, so I ended up gutting it out and writing all my own code, but keeping all the cool art. So, and I'll just talk about the future of JS games. That's an image of the future, right? Can you guess where that came from? So I think one of the things that I want to do, and feel free to steal this idea, but I'm going to do this year, is I showed you all that huge array, right, for putting all those bitmaps into place. I want to do something that's like a top-down type game, like Legend of Zelda or something, like old Legend of Zelda, top-down, and I want to take those arrays, feed them into an LLM, and say randomly generate levels so that every person that plays the game gets a different experience. And then have a little thumbs up, thumbs down. We say people were like, oh, do you like this level? And they can just hit thumbs up. Yeah, I like forest level. I like water level. And then feed that back into the LLM and give them more of the type of levels they want. I think that's completely possible. Right now, it only exists in my head, of course. And like I said, feel free to steal the idea, anybody who wants to do it. But I think it would be really cool to implement AI in that way to like make it so it's a different experience for every single person. And if somebody's like, you know, I don't really like these type of levels, fine, you'll never see them again. Now you'll see a different set of levels. And so I think that would be cool. And I am going to wrap this up with why you should build retro games. I hope I've convinced you in 25 minutes, but nostalgia is fun. So every time I fire up Mike Tyson's Punch-Out or something, or Excitebike or whatever, I'm instantly transported back into 1991, you know, like sitting on a living room floor, playing a Nintendo. Social media didn't exist. It was great, great time. Great time to be alive, let me tell you. And less complexity because of the mechanics of these games and the graphics of these games. They're not very complex. So you saw the minimal amount of code. I've built way bigger games, and it's still far less complex than if you're trying to make, you know, Fortnite or something. It's just a level of complexity is super low because that's how it was back then. That's how they had to be, right? They had to be low res, low complexity. And the biggest reason you should build retro games is the community and tool set. I should have brought up itch.io, but I will definitely add it to the slides that we put up there. Itch.io is like the website that covers all the things. And so on there, you will find sprite sets. So like I said, I'm not an artist, so I bought a sprite set for $20 that has bushes and trees and people and houses and all this stuff. And then they also have tools. That's where I found Tiled and several of those other tools. They have those on there. They're free to download with a suggested donation. And I've thrown a few $100s at itch.io over a couple years just because, you know, if they make it and put it up there, then I'm like, yeah, cool. We'll send you some money. So it's really cool. And I should probably mention, I wrote a book, Coding with AI. I've got a code so you can get it 50% off if anyone's interested in it. And this is basically, I wrote something that's kind of anti-vibe coding. This book is basically how developers can augment their existing skills, and definitely does not advocate for what I talked about with the race car game where you just sit down and but the book is basically, here's how you can augment your own skills, and here's how you can check yourself and teach yourself with AI and using coding. And I do have one chapter on vibe coding. And also, I work for a company called CodeCloud. We do online instruction, a lot of stuff around Kubernetes, DevOps, IT infrastructure. I am the AI person right now, and I need help. So we've got a lot of courses on AI. So if you're interested in possibly becoming an instructor, because we do a lot of part-time contracted type stuff, you know, it doesn't have to, you can keep your full-time job. In fact, a lot of our part-time instructors prefer to work their full-time job because that's what they want to do, and then they do this on the side. So contact me. That's it. Thank you all for coming out here. And I have to do the audience selfie. So everybody pretend like they're asleep. Well, that's awesome. But seriously, thank you everybody for coming in and seeing my nonsense.
Great job, man. I really enjoyed that.
Really? Good. That's cool.
I'm actually like thinking maybe I should go build some dino games for my kids.
Yeah, heck yeah, man. Thank you. It helped. Oh, thanks.
Well done. Well done. I had no idea that thing existed.
Yeah, that was
Okay.
And go testing.
Can I test it? Oh, testing. All right, check, 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 check. Yep. All right, mic is live. We're good to go. Welcome, everybody. Just a heads up, I do speak kind of quickly, and this typically is a 45-minute talk that I've condensed down to 25 minutes, so I am going to speak fast. We're going to cover a lot of ground. I love to code. I'm sure we all do. I did not start coding. I actually started in IT. I used to manage systems, but the coding bug bit me way back in the MySpace days when I learned how to customize my profile. Any other MySpace OG developers? Oh, wow, a lot of people here. That's great. So I got my start as a software developer working in IT when my boss came to me and said, hey, we are paying this consulting company to make an API for us. We want to take it in-house. Would you like to do it? And I'm like, heck yes, I want to do it because I want to write code. So I build my first feature. I'm ready to ship it, and I call the consultant and I say, how do I get this thing live, right? Because I'm expecting, based on my experience, I'm going to be building things. I'm going to be FTPing things from server A to server B and restarting and basically doing that, right? He goes, no, all you got to do is just merge to main. And I'm like, my mind is completely blown at this possibility. And this is before the popularity of services like Vercel and Netlify. So what we are going to do today is we're going to break down how Netlify works. I've never worked for Netlify. I am not giving away any trade secrets. So this is all my inference. But that is me. My name is Brian Morrison. I'm a senior developer educator for a company called Clerk. Clerk's a user management platform. My job is basically to help people online learn how to use the product in the most optimal and efficient way, and just generally nerd out with people on the internet, which is actually a pretty cool gig. But as I said before that, I was a full stack developer. I was a systems engineer. I've been networking. I have an amazing wife and 3 beautiful children, all crazy psychotic boys, but I love them to death. And I'm also a gamer. And my game of choice is Destiny 2. For those of you who know me well, that's not a surprise. And that's going to be an important detail as we continue on. So as I said, we're going to look in the process of deploying to Netlify. Who is not deployed to Netlify or Vercel, by the way? OK, good. We actually do have a couple people, so that's great. So step 1 of getting code onto something like Netlify is you write your code. This is kind of generally the experience. You write code, you commit your code, push it up to GitHub. Netlify comes along and works some kind of magic behind the scenes, and then all of a sudden, your site is live. So the question we're going to answer today is how this magic works. If I had to break it down into a single word, I would say DevOps. Automation is another great word that can swap in there. But let's take a look inside of Netlify's black box. These are the 5 phases that are shown in the Netlify dashboard when you go to deploy a website. This is pulled directly from the configuration of a website. If you go there, you'll see these things: initialize, build, deploy, cleanup, post-processing. Taking a deeper look into what each one of these things do, This is the initialization process. We're going to start by spinning up a build container. Back, like I said, in the old days, you used to have dedicated build servers that had all of your underlying dependencies pre-installed, so you can build things like Node, NPM, so on and so forth. Now we use containers because it's a small, ephemeral thing that we can spin up, do our work, tear it down, done with it, toss it away, right? Netlify also installs dependencies, so if you're in a Node.js project, npm installs run here. The next phase is build. We're going to build the site, npm run build. If you also have serverless functions, which Netlify does support, your serverless function binaries are going to be built here as well. Step 3 is deploy. We're going to take those artifacts, that's a fancy term for the deliverables of the build process, and we're going to put them onto publicly accessible servers because people need to access them in some way or some shape, way, form, etc. Your serverless binaries are going to go there. Files inside of their CDN is going to be replaced. For those of you who don't know what a CDN is, it is essentially a global network of access points around the entire world that can put code geographically close to people who need to use it. This means that if you have an application that is used by people in the US as well as Europe, if your code is closer to them, they can access it faster because Netlify still has not figured out how to solve the problem of physics, so that helps. And then finally, we update routing, so if you put new stuff into Netlify's network, it's accessible. Cleanup is actually a pretty cool phase here, I think, at least for what they do. They cache the artifacts for rollback. So if you add some code to a website that isn't quite working the way you expect it to, and you see it, and it kind of gives you that, oh, sugar moment of what's going on there, you can press the button and roll it back. We're also going to cache our build dependencies here, so you don't have to pull down nearly as much the next time you go to run your builds. And then finally, post-processing is Netlify-specific stuff. This is a screenshot from an application that I worked on. I use Netlify forms inside of this application, so this is where all that stuff is kind of set up on their end. So now I'm going to give you some categories of tools for you to explore to build your own black box, right? Where the whole goal is to get away from using Netlify or Vercel or whatever to build something yourself and get excited, just like I was way back in the day. So the first tool, this may not be in the same sense of the way we think about orchestration like Kubernetes, but I still call this orchestration as a category of tools. This is like your puppet master. This is what's going to pull all the strings, run all the commands, move the code from point A to point B, and do all the stuff behind the scenes to create your artifacts, right? We need a place to store stuff. File storage and hosting is important. Content delivery network, CDN. I don't think I pulled out the full acronym, but that's what that is, and we talked about that for a brief moment earlier. Backend code execution. Most websites are not static websites. You need a way to interact with your backend with the database and somehow, so you need a way to execute code outside of the user's browser. We have routing. Again, when you're pushing new things out onto the public internet, whether it's AWS, Azure, any cloud provider, those rules need to get updated so this way people can access your new stuff. Authentication. I left this in here because Netlify, I'm not sure if they still do, they did at one point have an identity service. I'm a fan of using professional services for authentication. I work for one. Kind of feels self-serving to leave this in, but I wrote this talk before I ever worked for one of these, so I left it in. Plus, it's my talk, get off my lawn. And don't tell clerk I said this, but infrastructure as code is probably my favorite category of tool here. This also feels pretty magical even behind the scenes. It basically lets you define all your components of infrastructure inside of a glorified text file. The IAC tooling will look at that and find out what do I want, what exists right now, and it will try and make them match as best as possible. And that brings me to Guardian Forge. I told you my game of choice, Destiny 2, was going to be important. Guardian Forge is my application that I built for players of Destiny 2. It lets you take snapshots of your character data in-game, optimized for specific activities. I built this, the idea came to me because I like watching YouTube videos of how to properly optimize my characters for harder activities inside of the game. And I'm like, as soon as I finish that video, information's gone, right? A shareable link of all that stuff that if somebody's character would be pretty cool. So that's what my service does. I am using a bunch of services behind the scene in order to deploy updates for Guardian Forge, and it's way more complex than it needs to be, but nonetheless, it's really good for doing this talk, so we're going to dive through them all. For orchestration, I'm using GitHub Actions. Whenever I push something up into my repository, GitHub Actions notices it and runs a bunch of scripts and workflows in order to make my application live. For IAC, I'm using AWS SAM. SAM stands for Serverless Application Model. It basically takes that giant text file, which in my case is YAML, and creates all of the necessary components inside of AWS for me to be able to host an environment for Guardian Forge. For file storage and hosting, I'm using AWS S3. In a nutshell, files and folders stored up inside of AWS. It gets a little deeper than that, but you can also make these files publicly accessible. So I use it to store all the artifacts for the publicly accessible web versions of Guardian Forge. Content Delivery Network is going to be CloudFront. It is AWS's flavor of a CDN. Routing. I included CloudFront in this as well, being highlighted, because CloudFront does actually do a little bit of routing for me. So Guardian Forge is actually 3 front-end applications. I have 3 apps, one for the main website, one for docs, one for the blog. And CloudFront can actually intelligently decide what, depending on the path that's coming in, which subfolder of my site bucket it's going to route that request to serve up the correct React application. Oh, backing up, hold on 1 second. Route 53 is AWS's domain registration service. The reason I'm using that is because I can programmatically hook into that to create subdomains. If anyone has worked with preview branches inside of Netlify, you'll know that you can actually create a separate branch, create a pull request back to main, and then see a preview of that environment without actually affecting your production. So I'm using Route 53 for that. And then API Gateway on the bottom there routes backend requests to my Lambda functions, which is all these serverless functions that do all sorts of different things depending on how the request comes into the backend. For completion, I included Bungie's actual OAuth. Bungie's the creator of Destiny. I'm just using Bungie's OAuth system because if you're going to use Guardian Forge, you need to be playing Destiny, and you need a Bungie account, so there's no need for me to use any other providers beyond that. So there are a couple of other services that we did not talk about in this diagram we're going to get to. The first one is DynamoDB. That is a NoSQL database that works inside of AWS. That is deployable from AWS SAM. If you're using something with Netlify, I don't think to this day they support an in-house database system, so you have to go outside of Netlify to do that. AWS has it included, and I can configure it with SAM. I also have SQS there. Back up just a moment. Getting a little click happy here. Hold on 1 second. So SQS is a queuing service. And for those of you who are not familiar with queuing, it's a fairly simple concept, but can also get technically deep. You have one application on the left, right. You have 2 applications right on either side and a queue in the middle. Application A drops a message onto the queue. Application B picks that message up from the queue, does stuff with it. It enables asynchronous processing of data within the Guardian Forge backend, which I'm going to show you why that is important right now. So I've rearranged my diagram to show all of the things that happen when somebody creates a build. A build in Guardian Forge is kind of that core entity that creates the shareable links, right? And in a nutshell, it just said the user's computer is just going to send a JSON body payload back to my backend. Route 53 is going to help resolve it to the correct API gateway instance, and that JSON payload is then going to go to a Lambda function, which is going to do some stuff with it. There are 5 distinct steps that need to happen for the build creation process to be complete, but only the first 2 are required before I can respond to the user and say, here's your link, have a nice day, go do what you will with it, right? First thing is I'm going to take that JSON payload and I'm going to store it directly in an S3 bucket. Again, since S3 allows me to access files to the public internet, I don't need to consume database storage, which is more expensive than S3, so I have some cost savings that I'm able to implement with this approach. It's also going to be faster since I can just request that JSON file to render that data on the page. I don't have to actually do a lookup inside of the database. But then for some features, I actually do need a stub of that data stored inside of DynamoDB. That's the first 2 steps. That's all that needs to happen before I can give the user that link so they can start sharing it. On the back end, the next thing that's going to happen is that Lambda function is going to drop that JSON payload onto an SQS queue, which is then going to get picked up by another Lambda function to do some post-processing stuff asynchronously. First thing we're going to do is we're going to create a nice preview image. So this way when somebody shares a link on Twitter, by the way, it is still Twitter. I am dying on that hill, okay? That gets stored next to the build data inside of the S3 bucket. So this way, when it gets shared, that's the open graph image that's going to be pulled up to preview inside there. The next thing it's going to do is it's going to transform that data and ship it off to Algolia, which I use to power search on the website. That does not need to happen before that link is shareable, which is why I can handle it after the fact. Sure, somebody who's searching might take an extra couple seconds before they can see it in the index, but that's a hit I'm willing to take. And next, because I like the dopamine hit that people are actually using my stuff, I will send myself a little message to feel good about the things that I built in Discord. Okay, back to where we were before. This is our original diagram. So what happens if I create a branch called CYC demo, and I create a pull request? GitHub Actions is going to take that, use AWS SAM, and spin up a completely fresh vanilla environment of Guardian Forge for me to test out that preview branch. And that is all powered by the IAC tooling that I've created. We've looked at this visually. Let's dive into a little bit of code now. Again, since this is a kind of a lightning version of the talk, the original talk actually has a live demo of me doing this stuff, but we're just going to dive into some of the files here. All of the code is open source. You can access it using that URL. You don't have to write it down now if you are interested in diving into it. I got a QR code for you to scan later that'll show you all of the resources and stuff we're talking about here today. So this is a YAML file. This is actually defines the workflow for GitHub Actions to deploy the front end of Guardian Forge. I wanted to start by keying in on line 3, the on section. These are actually the triggers that are going to start the process of deploying this. You will notice on line, 9 there, that I'm only monitoring changes to files inside of the front-end/public folder. I like to work inside of a monorepo. I like my front-end code and my back-end code staying in the same repository. And my back-end code's actually all written in Go. I don't use JavaScript on the back-end. So that means that if I need to go to Guardian Forge and say I typo something, I don't need to actually redeploy the whole damn thing. I can just deploy the front end using this workflow. Next step here is we're looking at environment variables that are set for all of the jobs for this GitHub Actions execution. So I'm setting my AWS keys here. This is more or less a programmatic username and password, so this way GitHub Actions has the ability to hook into my AWS account to deploy resources. And depending on the environment that I have set here, I can deploy to my production account versus a test account, whatever I want here. Now we're going to look at the start of this job definition, which is going to execute all of the sequential steps required to get Guardian Forge out into the public. The main thing that I want to call out here is on line 20, I have in runs on Ubuntu/latest. Everything that is going to happen inside of this workflow is going to be in an Ubuntu machine. But if anyone here has ever actually built anything for the Mac ecosystem, for Apple, iPhone, Mac, whatever, you need to build on a Mac. You can't do it on any other machine. So this is kind of the first main superpower you get by doing this, is you can specify the underlying operating system container that's going to build whatever you're trying to build. You're not limited to just shipping websites or using Linux or whatever Netlify uses behind the scenes. We're going to cruise through all the steps of this just to kind of try and one-for-one match this up with a little bit of what Netlify does. The first thing I'm doing here is I'm extracting the branch name for which the PR is created, and this is how I can create the specific environments inside of AWS for each individual pull request. Checkout essentially clones the repository inside of the build container. I told you I'm crazy and have 3 applications. I have a shared component library, so I'm able to use that and build that for the front end here. Transform configs. We didn't really see this inside of Netlify's dashboard, but Netlify supports different environment variables depending on if you're in a production branch or a preview environment. You don't want your previews connecting to your production database, so this is how some of this stuff gets set. And I had to use some bash scripts in order to pull this magic off inside of GitHub Actions. npm install build, pretty self-explanatory. We're building stuff here. Clean deploy directory. I host my sites in S3. I host the applications in S3. I'm reaching into S3. I'm clearing out the old artifacts. I'm going to copy the new artifacts and push them into S3. And then I'm going to invalidate my cache. This is the CDN. I don't do the same thing that Netlify does where I push the artifacts out into the CDN. I instead just clear it out. So the first person that tries to access it might see a little bit of performance hit, but it's going to populate after that, and everyone else should see it nice and quickly. This is the GitHub Action workflow for the back end. We're going to spend less time here because a lot of it's more of the same. But again, on my triggers, I'm only monitoring code that is inside of my backend folder, so I'm not redeploying the entire front end whenever I make changes here. Next up, I want to highlight this step here. This is a step template that is provided by AWS to install the AWS SAM CLI inside of my build container. I highlight this because you can customize the containers and install your own tooling inside of those containers if you absolutely need to. So you get full flexibility with this kind of approach of what you're doing. And then finally, this last step, build and deploy. This uses make to call a bunch of shell scripts that are going to transform the configurations and then use AWS SAM deploy, I think is the command, in order to push things out. But I also wanted to call out here, this is running a set of bash scripts. This is running inside of my backend/stack directory, so I can set the working directory. I can set custom environment variables in order to get very granular with how I want to actually execute these scripts behind the scenes. So again, just leaning into the theme of full flexibility here. And then finally, here is my SAM template. This is that text file that defines all of my AWS resources that I need. First thing I want to call out here is it's parameterized, and this is how I can pass in the branch name for the specific environment and then ship the resources and name them appropriately. As shown down here, this is the definition for my S3 bucket, which holds all the sites here. On line 101 of this sample, you can actually see that I'm concatenating Guardian Forge / whatever the environment name is / site. So I can go into my AWS account and look at the individual buckets inside of there and identify which files are in which environment and get a little more into the actual files if I need to debug things. And then just showing that we can have more than just S3 buckets here. This is a get users function. This is one of my Lambda functions that's run whenever somebody uses a website. And for a dramatic effect, this is the entire file. So you can see there's a lot of stuff that I'm able to do with this single file. I don't think SAM supports breaking this up. It didn't when I started creating this. I'm not sure if it does now. But the real question behind my talk is, why the hell would any of you want to do this when you can just merge code and Netlify will ship it for you? And I have a couple answers to that question. The first one is, the more skills you have, the more opportunities you have. Everyone has told everyone is spreading this message that AI is going to come and take all of our jobs for us. And I hope there are a lot of you that don't actually believe that, because I don't believe it. But that doesn't mean the executives at your companies don't believe that. So they're laying people off left and right just to try and make that cost savings, right? And if you're in part of a layoff wave of 10,000 people, you are now competing with 9,999 other people to get a job just so you can put food on the table. You might be more attractive if you're able to do this plus React versus somebody who's just really skilled in React, because you can provide more value to companies. The next step is you have more services you can use. Netlify doesn't have a queuing service. It doesn't have a built-in database like I showed you that I was able to pull off just using AWS. And this is my favorite one, which is fundamental knowledge. Part of my job for Clerk is I go online on Twitter and I find people who are having issues using the service and I try and help them. You know, hey, let's jam. Let's figure out how we can build something for your solution together, right? And for some reason, there are people that have made it their life's mission to try and convince the world that you don't need to use a third-party authentication service. Build your own auth. And to them I say, yes, build your own auth, because you should know how to build your own auth. You should know how to build your own backend CI pipelines. You should know how to fiddle with servers and figure out how to do all this stuff, because only once you have the experience of doing this stuff will you actually be able to make an educated decision whether or not any of this is worth it for you, right? Like, this is some crazy monstrosity that I put together, you know, mainly because I was trying to learn this stuff. But I use Vercel for most of my stuff these days because they make it easy. But at the very least, what I can do, now that I know it, is I can appreciate what Vercel and Netlify do for me, and then I don't have to worry about it. And I fully respect anyone here who does not want to take this on and just use the available tooling. But let's say you're on the other side of that coin and you're like me and this stuff really gets you fired up, right? So I got some tips to get you started. The first one is start small and grow. Don't do something like what I did unless you want to, then by all means do it. But you can create something very simple like a GitHub Actions that uses the Netlify CLI to deploy the site for you, right? Instead of relying on Netlify to come into GitHub and grab your code and pull it to them, use the CLI in a bash script to push it to them instead. You'll get the same effect, mostly, and you'll learn something along the way. Next up, you should know your ecosystem. I work a lot in the JavaScript. One second, I need to take a drink of water here. I work a lot in JavaScript and TypeScript these days with the work that I do. But as I mentioned, Guardian Forge's backend is built with Go. Before that, I actually did a lot of work in the .NET ecosystem. That was my bread and butter for a long time. All of those ecosystems build things in different ways, ship things in different ways. So the more knowledge you have in your particular flavor of language or framework that you're using, the easier you're going to be able to build and debug these types of pipelines. Next up, learn how to automate. A lot of things in my workflows were all bash scripts that were cobbled together to create some desired outcome, right? So whether it's bash or PowerShell or whatever kind of shell you want to learn, learning how to automate stuff with shell scripts makes this whole process work a whole lot better. Gives you a lot of flexibility. If at first you don't succeed, audience participation. Moms and dads told us we fall off a bike, try again. Building DevOps pipelines take this concept a little bit farther. Okay? If you're going to get started in this, you're not going to build something and get it right the first time or the second time or the 100th time. And that's kind of just the way that it goes. You're going to build something and just kind of trial and error your way through it. Last year when I gave this talk, I built the demo that actually supports branch-based deployments. And it took me a couple of hours to like fiddle through it and get it all working the way that it was supposed to, so it was in a nice, repeatable way. That's just kind of the nature of the beast. But once it actually works, I mean, it's like your mind's blown. You feel great. It's such a fulfilling feeling. The last step that I have for you is there is no one right way to do a lot of this stuff. If you get excited about this and you go out and you buy the DevOps literature books, right, you will find out that they say there are 8 distinct phases that you should follow in order to implement DevOps in your environment. And those really should be considered kind of like guidelines or best practices. I've worked at several companies where I've been relatively in charge or involved in these types of pipelines, and not a single one of them ever followed all of the 8 phases to the T the way that they were supposed to. So what I like to tell people is as long as you can build and ship your code, you know, get it from works on my machine to works on everybody's machine, do it quickly, do it securely, efficiently, ideally testably, test it, I don't know, you know, tests are good. As long as you can get it from point A to point B and do it in a repeatable way, it's a good thing. And finally, I work in developer marketing, and developer marketers love their logos, so I have a bunch of logos on the screen for you, okay? I don't expect you to know what all those are, but there is a QR code there you can scan that will link you to a page on my website that has a bunch of resources that can help you get going with this process, whether it's guides and tutorials that I have created over the years, to links to a lot of these services here, and then some. There's also a recording for the whole talk, which contains the actual live demo portion of this. And then once this talk gets fully published and I have the video copy, I'll link that there as well. By the way, if anyone has any resources that they think others would benefit from, please DM me. And that goes for anybody out there watching live. If you want to get in touch with me, DM me. And let's nerd out about this stuff. Thank you for joining my talk. My name is Brian Morrison. 47 seconds to spare. Whew, we did it. Thank you. All right, any questions, we'll take it out in the hallway track. Or again, DM me online. That's my contact info.
next speaker, Alzar Hernandez.
All right, thank you guys so much.
Yeah.
All right. So on the Commit Your Code website, it was going to be a talk about React accessibility, but I changed the talk, so sorry if you were here for that. But we're going to be talking about automation systems with NestJS. So NestJS is a back-end JavaScript framework that we can use to really organize and modularize our code. So if you want to go ahead, for those people, my lovely folks on the stream, if you want to go ahead and scan that or whatever, we'll start with the talk. So, all right. So the overview of concepts is just one of the things is briefly talk about automation. And so really, this talk stems from one of the first responsibilities I had as a software engineer in my current role was to automate some processes that involved a lot of human interaction. So basically we had a lot of, we had processing data that a lot of people had to touch. And so my first task was to eliminate that need for the human person to touch it, right? But don't worry, those people still had jobs. Doesn't mean anything, it just got reallocated somewhere, right? So yeah, the topic of automation is just how do we use code, how do we use software to make things go from point A to point B with as little human interaction as possible. So the role of JavaScript, well, this is a JavaScript talk. And so at the time, I came in as a front-end developer, and I didn't know any back-end languages, like the traditional ones, Java, Python, C#, really well to really grab my teeth on this, this goal, this problem. So I was like, what can I do with JavaScript that can still give me that ability to organize my code and really be efficient with it. So there is where NestJS comes in. And it really follows the OOP, the MVC pattern that you see in a lot of these other frameworks. I'm talking Java, Spring Boot, or the .NET framework in C#. This kind of does it, but in JavaScript. So I'll show you throughout the presentation, I'll show you guys some examples, and then what we did to solve this problem of automation, which is really cool because it was kind of out of the box, something that I'd never really done before. So, all right. So I wanted to make this a little fun, I guess. So I have to think about it in terms of a context, right? So our friend Bob, our client Bob, has decided that he needs to automate his contracts. So basically, he runs a small construction business. If you don't know who this is Bob the Builder. And he's overwhelmed. So the guy is too busy constructing things and running a cartoon show. So he comes to me, and he wants to automate incoming contracts, so clients that want to use his services to do his work, right? But he needs to reduce that time because he doesn't have anyone to help him. So the solution that I proposed, which is kind of similar to what I did actually in real life, was to take Bob's current CRM. So he had a primary data source of people that went in and imported contracts or filled out forms, anything that got the data into Bob's system. He already had that, so we are not going to mess with that, really, if anything. But the rest of the tools that we did are things that we were going to add to his current infrastructure. So the first thing is MongoDB as the intermediary database. But really, this can be anything. This is the one that I did because there's examples in this that are specific to MongoDB, but I'm sure they all exist in SQL as well. We have the RPA tools, so specifically robotic process automation. It's just browser automation. Let's say there is a process that needs to be accomplished, but there is no API for whatever reason. You could, in theory, repurpose like Playwright, Selenium, tools that would be used for QA. You could repurpose those to run in an isolated environment for automation. But the first two, UiPath and Power Automate, are really the ones that I think of with automation. But other than that, that's pretty much all we need to worry about. And then the thing that we actually are talking about today is NestJS, which is the central server that is going to handle all of these different talks. So the bottom diagram that we have is essentially what, at every stopping point, every arrow going from one box to another to the diamond, there was an interaction that required someone to actually physically check the contract for whatever, right? So Bob wants to automate all of that. And so with these tools, we are going to do just that. So I'll talk a little bit about architecture. Again, we have the 3 databases, or the 3 touch points. So we have the primary data source. We have the intermediary database. I can't say that word today. And we have the automation tooling. And so basically, if you going back to the diagram, it's going to go from Bob's CRM, we're going to do some things, and we're going to write it right back, right? So now, NestJS. Let's talk about a little bit about NestJS. So I mentioned the modularity that you can do with NestJS. You can organize things into modules. You can organize code. You can organize functions. You can do all that in modules to keep code as clean and concise and reusable. It supports solid. So when you go on the NestJS website, they really talk about that, just having those principles really laid out within the framework. And really, at first I saw that and I was like, okay, well, this is great. Let's work with it. But as I started to develop, my love for backend increased. But also, I was thinking in terms of if I were to leave this project and give it to another developer who may be more back-end heavy, who may come from a Java or C# background, I wanted to make sure that they had that ability to pick up where we left off. And the only difference really would be that it's in TypeScript, right? And it's just syntax is a little different, but otherwise it's still the same ideas. So separation of concerns. So let's say, for instance, Bob wants to extend his needs. He has another problem, and we need to somehow improve on one side of the system without messing with anything else. And that's really where NestJS can be beneficial, because then we also are thinking in terms of separating things, much like MVC, much like separation of concerns, and making sure that we are not breaking things as we're trying to fix other things. So now we'll get started with like how it looks like in NestJS, right? So schema. So Bob has contracts that come in, and they all have different entities. Ooh, that's pretty small, but and it has different attributes to entities. It has status, it has the customer name. Just know that that's how we define our data, and we make sure that it is clear and concise as at every point that we have a contract come in, right? The login info, if you guys can see that, it's really for the automation tool. So in the event that for some reason then you needed a login or something, you could store that. Obviously, security is a big concern there, because then you don't want to be storing credentials there. But again, that's one of the things that you could do to add to that automation for the browsers. All right, so let's talk about how to set up modules in NestJS. So really, if you look at the diagram, we have the root, and we have all these other wonderful JavaScript specific files that you see. But then in the source file is really where things start to divide up, right? So we have the contracts. So you see that right there, I have the contracts directory. I'll say directory, but really that's the module. That's where you're going to put all your things pertaining to the contract in the situation, or really any module you have. You put all the specific tools that you need, the specific code that is pertaining to that to separate it. Then we'll see in a little bit, we have the app module, which is the global thing. That's where you import all your modules so that things can work, right? Let's see. All right, so we're starting with the contract module, because then we're trying to help Bob out. And when we look at the contract module, you'll see it's decorated. Again, if you come from a Java or a C# background, this will kind of look familiar in the sense of like you'll see like the @ and then whatever import you're trying to use, or whatever function you try to use, method. So yeah, other than that, it's pretty simple. It's pretty straightforward. You have the imports. I use type ORM. I did that just to use an ORM. It's a little more. It's still JavaScript, and you can use so many different packages. You can still run things like you would in an Express app or any other framework for Node.js. But this just kind of makes it really clear for you. So I use TypeORM, and then the providers you'll see is a service file, which we'll get into in a little bit. And then you export the class. Now, let's say I want to put in a database, so I'm going to use the MongoDB piece, right? So I will grab, specifically, I will grab the ORM of my choosing, or MongoDB has a great Node.js driver. It's super awesome. So you could also put that in here as well. But it's kind of where you put your config for your database, and you do all those other things that you have to put in. And then the entities, which is the contract that the model that we just had, we also put that in there as well. Now this is the app. This is the global module that we have that is at the root, essentially as close to the root of the project. And that's where we put in everything. So I see there's the database module that we just went through. We have the contracts module. And then we have a config module that we need to use for, I want to say it was for TypeORM, as well as the entity as well. And then the app controller, the app service. And so when you route, the app controller would be the route of the URL, right? So whatever you want to put there, it's really great. You can put that in there. We'll talk more about that too with when you start up. If you want to, we'll get more into it, but as you start, if there's an action that you want to have at the beginning of the starting of the server, you put that in the app module files, whatever you need to put in. So now we have the controller and the service layers. So again, if you have seen that before, you've seen controller, you set up your endpoints. I'm talking REST here. And then the service files, you will put in your logic, whatever you need to put in to make your endpoint do whatever it has to do, return whatever it has to do. You have dependency injection. We'll go into that a little bit as well. You can export, or you export certain service files. You can start putting in service logic into different modules. I had to do that because I know at one point you may have something that's really good and really set up in one module, but then you may need to use it for a different controller. And for that, you do that, right? DTOs. So we're going to add, we'll talk more a little bit about that in the next slide. And then, again, you have your business logic. So, all right. So now, first thing is Bob wants us to have a contracts module or a contracts endpoint, so that way we can put in our specific contract data that he wants. So he wants to get a route that is a GET request to receive all contracts. Whatever reason, that's what Bob wants, that's what we're going to get, right? So you see I injected the module, so at the constructor. Again, this looks very familiar, right? If you come from a C# background and the Java background, it's like, this looks very familiar. Like, okay, I know where things are happening, right? And then I bring in the repository of the contracts so that I can get all that information. And then this specific line here, the contracts query, which is just finding all the contracts. Just something that it can happen in database in the ORM of your choosing. They may all be different, but it's all essentially the same thing, right? And then he's like, oh, I just want you to return that. When I hit this endpoint, I get all these contracts. Now, in our entity, there may be some fields that we don't want to have, right? So with that, we create a data transfer object so that we can shape the data that we want to return whenever you visit the endpoints. So for this specific thing, Bob wanted the customer order number. He wanted to see the name. He wanted to see the status, so if it had been accomplished or not, or any other status that he may want, and the email. Wanted that readily available. And so we wrote him exactly that. So we wrote some logic in that endpoint to fetch all the contracts and then return the data transfer object. And so you see that there. So now, let's go back to this. So now this would be great, but let's say for whatever reason we needed to reuse this code, this same idea, for something else, something different. It could be anything you can think of. You could just go ahead and just copy and paste this. Like, I know, like, it's pretty simple to just copy it and then put it in another endpoint or whatever. But then all of a sudden, what if something changes? then it's like, okay, well, now I got to go back and change every other point every other bit of logic, every other function that I did, and that's not reusable. That's not maintainable, right? It's going to get really poorly. It's just going to suck. It's going to suck. So that's where the service file comes in. And so let's take that code that we could possibly reuse, and let's put it in the contract service file. And so from there, we are able to then, in the next slide, see that now all of a sudden that endpoint is just the contract service method or function that we have right there from the service file. So now, if I want to reuse this code again, I just import the service file from the constructor and return whatever method that's already in that service file. So you can see it's really, 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 really clean. It's easier to maintain. You don't have to worry about the logic as far as like, I write it once, I can use it anywhere, right? All right, so that was just a basic overview of NestJS, what it can do. So now some of the things that we had to think about as far as how we're going to automate Bob's CRM, how we're going to automate things to work without us someone having to make a request and all that, right? So for all intents and purposes, Bob CRM has an API that we will connect to our Nest server, and it will send contracts to our Mongo instance. That part is already done. All we do is, that really will be the only human interaction, right? Someone writes a form down, fills a form out, and ships it to Bob CRM. That API connects to our NestJS server, and it goes to our MongoDB. Now the other three things, the database listener, the cron scheduling, and the queue service, those are things that will happen that will essentially replace some of those touch points that we were talking about earlier. And so this is an example of making a post request that sends the data to our MongoDB instance. And so right there, you can see that automatically right here, this line over here that says emitting event. So this event emitter.emit contract was created. It's kind of like a queuing service that you can also use to trigger the start of your automation. Okay. Let's see. Now, if I'm going to listen to the database, this is a really cool thing. I thought this was awesome. Is you can actually open up I don't know, I want to say underneath the hood, it's a socket or some kind of open connection that the server will be listening to the database for specific functionality. So if it's in MongoDB specifically, it's the insert. So that was the C of the CRUD operations. I was like, okay, whenever that happens, whenever something is created in MongoDB, whenever a contract comes in, then all this other stuff happens. And that's really cool because then on startup, you could, like at the start of the server, you could have this run so that all of a sudden you open up the connection, and when the server spins down, you can close the connection. Really cool stuff. So I actually did this. So whenever a contract would come in, we grabbed it and we did stuff that we had to do. So we added it to a queue in this instance, right? And then it gives in the logger right here, there's an object ID that we could keep a track of our jobs. So the other part is the cron scheduling. So if anyone has heard of cron jobs, it's just things that happen on a schedule. It can be whatever time, whatever day. It's really whatever you want to do. So there's, in this example, there's a runs every 30 seconds. And that's just to handle a database backup, just an example. Now, let's say the next thing is runs every day at 2 a.m. That's, there it just logs a daily report. But you could really do things like that. So in the event that you want to, let's say you want to batch update all these contracts, Bob says, hey, let's not mess with a report, or let's generate a report. I want to see a report by 8 a.m. the next day. Well, let's just do it when no one is requesting contracts, right? So the most probable time of that would be 2 a.m., right? Somewhere when everyone in the US is sleeping. So we can generate that. And that really is, it's crazy. Like if you test it when you're working with NestJS, you can really see like how it runs on the I think I want to say it's the date object of JavaScript. And it just runs and on cue, right on time, it does whatever you want it to do. That's really cool at that specific time. And so here's an optional controller. I've used it to where you could do a cron job. So this at cron, and then you put your time. And I've done it on a controller. And so it just hits a request. Or it really doesn't hit, it's in the controller, but you can make it run an asynchronous function. So, but here it's like, oh, you're just getting the crons and you want to get the jobs. So you have that queue system that you will, you can see your jobs. And you can see what's happening, what is in process, what failed. Really, right? It's not so much what went well, it's what didn't go well. So let's see. And then, yeah. So one of the few things that is really, really, really cool is you have NestJS as a server, but then you also use another microservice, such as like Redis or Kafka. And you're able to kind of start having this like really cool back and forth between the server and the microservice. And as you're going along and building or running through this process, you can take a history of what's going on and see what's happening between those two services. So, a few takeaways. If nothing else, you guys found another JavaScript framework that you can play around with. But really, really cool service. I know if I ever have another project to do that requires runtime JavaScript, I will most likely use NestJS. And so, yeah, thank you so much for coming to my talk, and use NestJS.
Testing, testing. Hello, hello, testing. All right. Testing, testing. Are you good on your end? All right, let's do it. All right, hey everyone, thank you so much for coming out. It is late on day 2, so I'm very grateful that you all made it to this. This is Serving Content on the Web from PHP to RSC and beyond. My name's Adam Rakis. This is a talk about how frameworks have evolved over the last decade or so, but we're not going to talk about superficial syntax because that's boring and it doesn't really matter. Instead, I want to talk about how frameworks have evolved to make better use of networks. What do I mean by that? To set the stage, I want you to stop thinking about your network as some simple thing against which you call fetch to quickly and reliably get data. That may be true when you're vibe coding a to-do list on localhost against an SQLite database, but in real life, your network is going to be a bit more like this. I want you to think about round trips across the network as the single most expensive thing your app can do, because most of the time it will be. I want to take a very, very quick tour back through history, what the web looks like all the way back in the 1990s. In the beginning, when you visited a website, the server would receive your request, read the URL, and it would send back a fully formed HTML page. We used to generate HTML on the server without JavaScript. And yes, I know we still do this, but it's less popular and it's less common. But yeah, you don't need JavaScript at all. Web servers have been doing this since day one. We used to use long forgotten obsolete languages like Perl and PHP. I'm kidding, I'm kidding, I'm kidding. And these sites could even be interactive, even way back then. And if you're thinking that you would do that with something like Fetch, Fetch wasn't added to the web until 2015. And if that 90s meme hits you really hard, you might be thinking about something like XML HTTP request object. But that wasn't added to the web until 2000, if you can believe that. And by the way, that's how you generate XHR code in 2025. Thank you, ChatGPT. And JavaScript itself wasn't even added to the web until 1995. Back then, if you wanted a website to be interactive, you would use a form. You would give your form a URL to send the form data to, give it an HTTP verb like post or get, and then when the user filled out your form and hit the submit button, all that data would get sent to wherever you told it to, and the whole page would post to that location and send you back either a new page or maybe the same page with some validation errors, whatever. If you tilt your head a little and squint, forms kind of were Fetch before we had Fetch. Fill out the form, and your whole page will post to that location and send you back some new content based on what you filled out. And even the page load is negotiable. Once JavaScript did come on the scene, tools like ASP.NET MVC allowed us to progressively enhance a form so that you could do all of that without the whole page posting back. JavaScript would catch the form submit, cancel it, and then do that under the covers so that the page would stay right where it was. And then long later, tools like Sapper and Remix came along and made those patterns popular again. But it's hard to build a rich, interactive experience with just HTML forms. So what do I mean by rich, interactive web experience? So this is the part of the talk where I get to show you what I work on at work. I work for Spotify, and I work for the Spotify for Artists app. And I've sent these slides up, and I got permission to share some screenshots of what S4A looks like. This is the site that our artists go on to manage, to look at their analytics, manage their whole stuff. But I need an artist to show, right? Because I can't be showing screenshots of Taylor Swift's, stream data and analytics. But I happen to know an artist who is on Spotify for Artists, Ken Wheeler. So just imagine you're a Spotify engineering vice president, and Adam Rackus sends you some slides to approve, and this is the first thing that you see. But he was a very good sport about it. So here's a few pages of S4A for Mr. Wheeler. Here's some listings of his tracks with some stream data. We have some data visualizations. This is his listener demographics. It's a massive sausage fest, as you can see. 94% dudes are listening to Ken Wheeler on Spotify. We have some data visualizations on his stream listeners. And of course, it's interactive. You punch the button, fill out the checkboxes, and we send some requests and update the data visualization. Here's what his profile page looks like. Let's take a step back and look at all the sources of data that are on this profile page, because that'll be relevant in a minute. If you start at the top right corner, that A inside the purple circle, that's the currently logged in user. That's me, A for Adam. We hit that. We hit an endpoint to retrieve the info for the currently logged in user. Going clockwise down, monthly listeners, we hit an endpoint to get that data. Artist pick. If you've ever been on the Spotify music player for an artist page, you might have noticed the artist pick. That's where the artist gets to select something that they want to feature for you. It might be an upcoming release, a recently released, maybe a re-release. Then going down, we've got more of his discography, and I lied, there's actually more sources of data. If you are a user who can access more than one artist, and I'm an employee so I can access all the artists, that list on the left is your recently viewed artist. We hit an endpoint for that. And I'm not happy to admit this, but those navigation links in the top left, we basically have to hit a separate endpoint for each of those endpoints, for each of those navigation links, to see if the current user can visit that link for the current artist. It's a whole thing. Could we build that in PHP? Yeah, for sure. Would we want to? Today, maybe. You have things like Laravel, which are amazing, especially with inertia that you can tack on. So Absolutely. But what about back in 2012? What would that have looked like? Generating the content on the server was easy. That's what we talked about a minute ago. That's what web servers have always done. They get the request and they spit out some HTML. It's easy. And don't let the data visualizations fool you. Those are just SVG tags. If the web server can generate HTML tags, it can generate SVG tags, no problem. But what about all the interactions? When you click the button, you need to get the click and then show the popover, and then you need to listen on click handlers for all those checkboxes, and then send a request, get the new SVG tags, and update your DOM. The artist pick, if Ken were to click there, we would sub in a little widget that would let Ken search through his discography to select something to set as his artist pick, hit save, and then that would update with the new artist pick. Generating the content in PHP would be easy. The problem is interactivity, and even then, it's not really a problem, and it's not that hard, but it's work. And we have tools that are really, really good for just that. Amazing tools. jQuery, yeah, great memories. Everyone loves jQuery. You never hear somebody complaining about jQuery. It's a great tool. So let's look at what that would look like if you wanted to go down this road. You could use PHP to generate all your content, send it down to the user, and now we need to make it interactive, right? So boom, you slap jQuery on it, and now you go to town, right? jQuery is an amazing tool to work with. You can select any content within your DOM and update it however you want. The API is fluent. It's a pleasure to work with. The problem is it works on CSS selectors, which are global. Spotify for Artists is managed by about 12 different teams of software engineers. So your app gets really, really big, and those CSS selectors are global, so you have to take a lot of care to make sure that nothing conflicts with each other. And at scale, it gets kind of annoying. We have an impedance mismatch. You've got, in this model, your server being generated, your content being generated on the server, but all your code for interactivity lives on the client. And so you have to make them play well together. And we've spent a lot of effort over those years figuring out ways to do that. But at some point, we said, why don't we just build the entire app on the client? And we started developing tools to let us do that. And then we developed better tools to let us do that even better. We said, let's just build this application one time on the client. We'll just sidestep the impedance mismatch. The server, instead of building all that content in PHP, we'll just spit out an empty HTML file that has a loading spinner, and then the client-side JavaScript will spin up and build our application. Since the server is only ever sending down a single shell of a page, we call these single-page applications. That's where the name comes from. So what's the problem? Not much. Ignore anyone on Twitter that says otherwise, but SPAs were great, and they still are great. And you can build an amazing product as an SPA, and you still can. And if your business failed, it wasn't because it was an SPA. And I'll double down on that. Sending down a few hundred kilobytes of JavaScript is not a problem. If your business failed, it wasn't because you had a few hundred kilobytes of JavaScript. SPAs will not work if your user has JavaScript disabled. Doesn't matter. Who cares? SPAs do suffer from bad SEO, so if that's a big concern for you, maybe think twice. But there is one substantial trade-off with SPAs, and it was hidden in plain sight the whole time. Remember I said our server sends down an empty shell of a page now? Well, that means that this becomes this now. When our server sends back our page, the user is just looking at an empty loading spinner. Our first render is now kind of useless. So the browser gets that empty shell of an HTML page, and it's going to parse it, and it's going to start seeing those script tags, and it's going to request those over the network. Maybe they're cached in a CDN close to you, or maybe they're not. Maybe they're cached in your browser if you've been to that website recently, or maybe they're not. Once the browser parses and reads that JavaScript, now your React components are going to come to life. And what's going to happen next? You're going to need to fetch some data, right? So that's going to be more round trips across the network. And eventually, all that will finish, and your app will start to display. And again, this is fine. Yes, it's a few hundred milliseconds. Unless you are doing heavy e-commerce or maybe some clickbait content slop, you're fine. This will be fine. But we're engineers, right? We want to do better if we can. It's not efficient. And so how can we fix this? We started building our entire app on the client. And the one thing we gave up was server-side rendering. And so now to get content in front of the user, it takes a little longer. So how can we fix that? You might be saying, well, this is a non-issue because React already supports server-side rendering. There are server-side APIs for React. It's not actually react.stringify, but conceptually that's what it is. It takes a component tree and it stringifies it into HTML. So on the server, you can stringify your app component tree into HTML and send that down the pipe. And then on the client, it gets the HTML and displays it. And then you use the client-side APIs. And it's not React DOM.render anymore, but that doesn't matter. You re-render the same component tree in the same place. And React will match everything up. And then it will spin up all your event handlers and effects. And that's called hydration. The problem is data, though. This is what it actually is going to look like because you have to fetch some data on the server in order to show something useful. And so at first it seems easy, right? Just fetch your data on the server and then pass your data to your component tree somehow. But then you have to do something unhinged. You have to take that data and you have to ram it into a script tag somewhere. Why would you do that? Well, because when you re-render your app on the client, you don't want those same components requesting the data because you already have it. You want to just read the data that was requested on the server and stuffed into your DOM somewhere. It's not hard, but it's really easy to get wrong. And this is where we start to see the evolution of meta frameworks, like Next. If you ask most people about Next, they'll say like file system-based routing. But solving this problem is, for me, one of the cooler things that Next did. It gave us a place to request data on the server, and then it gave us a place to define our component for a given route, and then those data just magically show up in your component. And Next does all that unhinged stuff in the background. If you ever inspect the HTML page, you will see that server-side data stuffed somewhere into a script tag as some sort of global data. Huge step forward, but now each of those routes has to be aware of all the data that that given route needs. Remember all the pieces of data that we needed for any given page? That's going to be really hard to stick inside of this one function, get server-side props. And there's no way to invalidate with the old next pages directory. So like if you're on a page, there's no way to say, hey, I've updated some data. I want to rerun that get server-side props function and push new data down. And what happens as you browse around your page? If you go from /tasks to /tasks12 to view a task, and then you browse back, do we want that get server-side props to rerun or just use the cached data? There's decent arguments either way, and you might want either, but your framework is going to have an opinion. We start to get that impedance mismatch back. And now we get the next sort of generation of meta frameworks, Remix and SvelteKit. These gave us the same sort of idea with get server-side props, but as loaders. And you can define many of them, and they're attached to individual chunks in your URL. And each of those different loaders can request a little piece of data for that given segment of the URL. And they can be invalidated. You now have ways to say, my data have changed, rerun all my loaders and get fresh data, or you can even say rerun an individual loader just to get those few pieces of data. And these frameworks even let you sort of make up your own loaders to split things up even more that have nothing to do with the URL. So you can really get fine-grained if you want to. Conceptually, here's what a loader looks like. If we're imagining like a Jira app, you might fetch your tasks and your epics and your milestones inside of a loader and send those down, and then your components can read it. But those loaders invalidate all or none, right? So if you were to edit, I'll get to that. And same as before, if you start browsing around and you come back to a page that you were at before, do you want to reuse cached data, or do you want the server to rerun and refetch? You might want either, and the framework might have an opinion either way. So you have to be aware of that. And like I said about revalidation, if you were to edit a task and then revalidate your loader, everything is going to rerun. You're going to rerun your tasks, refetch your epics, and refetch your milestones, even though you don't need to, even though the epics and milestones hadn't changed. This is fine, right? If that is what breaks your backend, then your backend was already broken. But remember, networks are unreliable, and the more pieces of data you're unnecessarily re-requesting, the greater the chances some of them might just be randomly slow for reasons that you have no control over. And yes, you can keep splitting up your data into those synthetic loaders that I mentioned, but that's going to get tedious. App directory inside of Next, React Server Components. that seemed really encouraging. You can just fetch data right in your components. But it's sort of the same problem. Next gives you those cool methods called revalidate tag, and they make it look like you're only re-requesting those pieces of data that you revalidated based on the tag. But no, your whole componentry is rerunning. It's on a server. It might be a Lambda function that didn't exist 2 seconds ago. It has no idea what your client-side React component tree is. It's going to rerun your entire React tree on the server and re-request everything and send it down. All revalidate tag is doing is it's kicking some things out of the cache. Vercel is assuming that you're caching all of these data in a JavaScript layer, which might or might not work for you. Still great, though. RSC was an amazing engineering feat, and it does fit very, very well for plenty of use cases, e-commerce in particular. But let's back up. Why can't we just kill this impedance mismatch once and for all? Remember how good life was in the SPA days? We had great data fetching opportunities, great data fetching tools. React Query. Who here uses React Query? I think a lot of you are lying. I think more people than that. But it's a very, very popular tool, about 15 million weekly downloads. It lets you do things like this. You can give it a hierarchical key. You can say epic, and then a given key, give it a function to fetch it, and some cache settings. And then it gives you URLs to invalidate your data at whatever fine-grained level you want. You can invalidate an individual epic or a whole family of queries and just wipe all of them out with the second one. That's how the hierarchical keys work. And you might say, well, why can't I use that with Remix? And you kind of can. There's this initial data property that React Query has. You can take your data from a Remix loader and just put it in a React Query hook like that. And that will take the server-fetched data from your loader, and React Query will work with that just fine. But as you start using your app and the epic ID changes, you need to be sure to remove that initial data so that React Query knows that I need to actually fetch the data. And then what happens when you invalidate your loader and it reruns and pushes you fresh data? Now you need to stick it back in as initial data again until you start using your app again and epic ID changes and you need to pop it back out. It gets kind of annoying. Life was so good in the SPA days. We were building the entire app on the client. Wouldn't it be so great if we could just have our server render the initial path and then just sort of go away and leave us with a beautiful client-driven SPA like we used to in the good old days? And this is where we come to the latest generation of meta frameworks. Solid Start was first. I wish Solid had more traction. It's really cool. TanStack Start, though, that is, as of a few days ago, finally in release candidate status. I urge you to check it out if you haven't already. But it gives you isomorphic loaders. What does that mean? It means the loaders run on the server or on the client. They will run on the server for the initial run when the user first browses to your web app. And after that, as you keep browsing around the web app, they run on the client. And it's deeply integrated with React Query. Let's take a look. A lot of code here. You don't have to focus on really any of it except for the stuff that's circled. The top loader function is the loader for that path. And the bottom function index, that is your component. React Query gives you URLs, or excuse me, it gives you APIs like ensure query data. That lets us say, make sure this data exists for this path inside my loader. And on the server, ensure query data will pretty much just always fetch the data on the server, and it will do all the work behind the scenes to make sure that those data are available for your component, and it will be there for the initial run. And then on the component, we say use query. What happens as the user starts browsing around and comes back to this same page? Like I said, it'll run on the client for all subsequent navigations. And the query client, that matters because when we say query client.ensure data on the client, it will look at the client-side cache that we already have with React Query. So you could have had, you can have 5 or 6 or 7 or however many calls like this in your loader. And as you come back to that page, you may have invalidated 1 or 2 of them using those same React Query APIs. And since this is running on the client, it will only re-request those few pieces of data that it needs based on what's cached, based on what you have kicked out of the cache. After the initial render, your loaders always run on the client. And that is significant because we have access to all the client-side goodies, our client-side data cache that React Query gives us. The impedance mismatch is basically gone. The server is just there to force down content quickly for that initial render, and then it just sort of gets out of our way and it gives us back the SPA that we've always had. Are there any downsides to this? If it wasn't for Dan Abramoff, I would have just gotten up here and say, this is just better. Sometimes one thing is just better than the alternatives, but there is one slight gotcha. If you screw up, your consequences will be a little bit worse. In Remix, if you have a data waterfall in your loader, it's not going to be that expensive because it's always going to be running on the server. And hopefully your web server is close to your database so that that latency is very, very, very small. But if that waterfall is running on the client, you're doing those huge round trips all the way across the internet. So just don't screw up, okay? Just don't do this. Don't have sequential awaits like that. Use promise.all or promise.all settled, and in reality, you'll probably want to be a little more robust than a stupid promise.all call. But conceptually, there's any number of ways to run code at the same time. And if you're saying, hey, my backend is kind of busted, I actually do genuinely need sequential calls like that, that's fine. Just put it in an API call somewhere, and those will always run on the server, an API route. And that'll always run on the server, and you call that API route from your loader. And then the waterfall will always run on the server. If your data are slow, all modern frameworks, Remix, Next, App Directory, TanStack, all of them support something called streaming. You can start your data fetch on the server, but not block the rendering, and then just push the data down when they're ready. How is that different than what we saw before with the initial sort of empty page? This is different because the data already do start to fetch as soon as you browse there, but we just don't block the render, and the server can push the data down whenever it's ready. Use it judiciously. If you stream every single piece of data on your page, the user is going to initially get met with like 20 loading spinners, and they're going to jarringly pop in. Maybe server render your main data and stream a few pieces of side data if you need to, if they're slow. Make sure there's no content shift, and so on. So this talk was not meant to be one framework is better than the other. What I was hoping the takeaway would be is to start to think about how your frameworks work and ask different questions than people sometimes ask. And if it seemed like I was ragging on Remix a lot, keep your eyes out for Remix 3, because I've heard they are adding isomorphic loaders. I've seen Ryan Florence claim that on Twitter. I hope that does wind up landing. I'm really sorry I didn't mention Nuxt at all, but I'm not a Vue person and I don't know anything about it. And Jessica's glaring at me. I've heard good things though, so check it out. Yeah, that's my talk. Thanks so much for listening.